In late September, a riddle of numbers began to circulate. A brief preprint by a well-known Harvard astrophysicist drew a careful line from an old puzzle to a new traveler, proposing that the 1977 WOW signal could align with the evolving path of 3IATLAS. Within days, observing dashboards at several facilities changed shape. Time blocks disappeared, justification fields turned vague, and antenna schedules leaned toward the same coordinates with unusual persistence. An amateur collective posted a narrowband trace that looked more like a wrist tap than weather. Then the post vanished, replaced by a note about routine maintenance. Meanwhile, a scheduling calendar for a national array showed midnight shifts that suddenly pointed at a high declination target with no public explanation. A Mars mission's housekeeping line recorded a short energy hiccup that sat inside the same few minutes as one of the rumored radio clusters. The public channels kept smiling. Anniversary posts, calibrations, pretty images. The gap said more than the words. Add the fragments, and the equation does not settle. Narrowband, repeating groups, sudden schedule pivots, a pulse near Mars that seems to nod at a radio whisper on Earth. Each piece is small. Together they lean in one direction, and the silence around them leans harder. These are enough to begin. They do not agree in every detail, yet they form a corridor, hold evidence and doubt at the same time. Let quiet tension sharpen the senses rather than flood them. We will keep the temperature low and the questions bright, following each claim to its edges and back, one measured step at a time. We will do this slowly and without hurry. So, before our journey begins, take a moment to like the video and subscribe, but only if you feel a genuine connection to the mysteries we explore here. And please let us know your location and the time where you are. These small markers on the map make our quiet community feel closer, even across oceans and deserts. Now, dim the lights, let the world outside fade away, and let's drift into the cosmos together. Picture a table in a dim archive room. On it lies a photocopy of that old 1977 trace, the one that turned a penciled exclamation into legend. Next to it, a single page from the new preprint suggests that the projected path of 3IATLAS crosses the historical beam in a way that is not obviously absurd. If that alignment is only geometry, it is a graceful accident. If it is a thread, it deserves a careful tug. Turn a page and a calendar appears. The week before October looks odd. 4 long rectangles mark midnight to dawn for a national radio array. Each entry claims software checkout or station upkeep. In a corner, a small coordinate log lists right ascensions that drift toward the same patch of sky at the same hours for several nights. Publicly, operations were ordinary. Privately, ears were turning to where 3IATLAS would be. A spectrogram from an amateur network lies beside the calendar. The line is faint but clean, a hairline near the neutral hydrogen neighborhood that thickens and thins with a patient rhythm. Over about 20 minutes, the trace breaks into clusters that repeat with short spacing between them. Natural radio noise tends to be messy and wide. This is narrow enough to suggest hardware. Hydrogen is a classic anchor, a common language in the sky. The spectrogram does not prove intention. It does not have to, not yet. It only says that someone should look again with better instruments and a stiff spine. Here we cluster the technicals, then we return to breath. The WOW event in 1977 was a narrowband spike that lasted about 70 seconds in one of 2 beams at roughly 1420 megahertz, the frequency of neutral hydrogen. Narrowband signals concentrate power into a tight slice of frequency, which is uncommon in most natural emitters. That is why many searches for intelligence sit near hydrogen and listen. Later surveys did not repeat the WOW event. The claims around 3IATLAS point to a low amplitude, repeating narrowband feature inside that neighborhood, grouped like framing and payload rather than a single tone. None of this is a verdict. It is a shape. Another envelope contains a Mars mission housekeeping note. The text is spare, just a timestamp and a brief flag for a short energy pulse detected by an instrument that usually listens to the space around the planet. The moment overlaps with one of the narrowband clusters reported on Earth. The correlation is temporal, not spatial, but it tugs the mind away from terrestrial interference. If two systems on two worlds feel the same nudge at the same second, then at minimum, the signal did not begin in a basement. Across the table sits a policy memo with the dry smell of committee paper. It reminds teams to avoid unreviewed public comments on interstellar objects during conjunction, and 2 route questions to a central office. The reasons are practical: protect ongoing analyses, prevent public anxiety over ambiguous data, maintain consistent messaging across agencies. Nothing in the memo is sinister. Nothing in it is generous. It is the language of people who want time to think without noise, and who know that quiet can look like a cover even when it is a cushion. The composition file is heavier. Reports of nickel without much iron point away from familiar comet classes. A carbon dioxide to water balance near 8:1 is cold and odd. Small course changes line up with periods when no visible outgassing was recorded, which nudges the mind toward guidance rather than random vents. None of these observations, standing alone, proves intention. Together, they build a profile that feels less like weather and more like choices made long before we noticed. Keep one image to steady the mind. The object is a dim shard against a winter sky, edges lit with a pale green rim as surrounding dust breathes. It crosses a quiet lane near Mars, and a hidden instrument blinks for half a second. What leaks into the silence is not heat or flare. It is rhythm, a ladder of pulses that falls into 3s and 2s and 1s, as patient as a hand tapping a table while the room clears. Ground the speculation before it climbs too high. Could a rolling body with patchy carbon dioxide frost produce jets with irregular cadence as it spins under sunlight? Perhaps, if the rotation is simple and the vents are few. Could local electronics have painted a false narrowband line onto a spectrogram? Yes, if shielding failed or a distant transmitter wandered through. Could the Mars pulse be a glitch in a sensor due for recalibration? Mission teams keep lists of those too. The natural explanations are not impossible. They are just required to arrive in a stack at the same time and point in the same direction. Still, the rumors persist because the pieces lean on each other. The narrowband whispers weigh more if a distant log ticks inside the same second. The scheduling shifts feel less like coincidence when phones go quiet and credentials change. The policy memo reads colder when the composition folder on the same table says nickel without iron, 8 without 1, path with a preference. None of this demands a verdict. It only licenses a deeper look. 2 hard facts formed the frame that holds the canvas. The wow signal was real, recorded by a large ear on Earth, and never replicated in the same way. Narrowband structure at or near the hydrogen line is a classic target in searches for intelligence, precisely because nature rarely prints such thin threads. These are anchors, not answers. They keep the edges straight while we test the paint. What follows is not prosecution, but process. We will treat the records as the work of a careful committee that prefers time and control. We will read the deletions and the new credentials as human reflex, not proof of a plot. We will also ask why the same numbers keep returning to the table. If 3IATLAS is a natural body, what mix of surfaces and spins produces a faint, repeatable, narrow thread near hydrogen that coincides with a pulse in Mars data? If it is not natural, why choose this patient cadence, this polite signal that almost hides inside noise? The file we open next mentions a request to hold a frequency clear for a late September window. The note is marked routine, but someone has underlined the window and written a small question mark. We spread a map of the sky and place a finger on the quiet lane that 3IATLAS is projected to cross. The question mark is not accusation, it is invitation. Between the lines, a protocol begins to appear. First, point everything that can listen and do not announce it. Second, tighten the keys to the rooms where the data arrives. Third, speak only when the words can be rehearsed and calm. The logic is simple. New claims attract noise. Once a crowd gathers, every gust looks like a pattern. The risk of being wrong rises. The temptation to wait grows. In that pause, the independent eyes matter more. Amateur arrays that publish quickly and accept the messiness of raw data often see surprising things first. Their weakness is calibration. Their strength is speed. Institutional arrays excel at the inverse. Between them, the overlap can be a narrow golden strip where the same thing appears twice. The Mars pulse, if it stands up to the next audit, would live in that strip. Return to the image for one more breath. The shard turns slowly, a dull body with a thin emerald edge. It does not blink like a beacon. It murmurs like a device that was never meant to shout. If it is engineered, the intent could be mundane. A power regulator, a thermal control system that hums when sunlight changes, a navigation ping meant for a companion that is no longer there. The meaning changes with the scale you choose. The rhythm remains. The last page in the folder is not data. It is a handwritten line. Wait until conjunction ends. The line is not a threat. It is a plan that uses the sun as a curtain. During the bright month, ground arrays lose their easy view, and space assets can choose what to stare at without a chorus of live commentary. If anyone wanted to test a hypothesis, to ping, to listen, to try a codebook, the glare would be an ally. We stop here at the edge of the blackout window, with the table cleared and the next envelope ready. The rumors behind the official silence have taken shape. They look less like smoke and more like scaffolding. If nothing is there, the scaffolding will come down cleanly. If something is there, the shape will begin to show when the curtain moves aside. Schedules leave fingerprints. When antennas pivot in quiet harmony and paperwork grows vague, you read the gaps. You stop listening to the press page and start listening to the clocks. A planning screen glows in a control room at 2 a.m. Blocks of time slide like tiles. A midnight allocation that once belonged to a galaxy survey now wears a neutral label and shifts to a high declination lane that matches the nightly march of 3IATLAS. Notes that used to say spiral arm mapping or pulsar timing now say engineering checkout. That phrase is a warm blanket. It covers just about anything. Operators live by disciplines that do not lie for long. Every pointed hour must be calibrated. Calibrators are bright, well-known sources near the target that tell you how the atmosphere is behaving and whether the electronics are in a good mood. They come with names you can guess if you know the sky. When the calibrators cluster around the same corridor on consecutive nights, the corridor is the point, whatever the form says. 2 hard facts anchor this picture. First, radio observatories around the world maintain target of opportunity programs that can preempt routine projects when something transient appears. It is how we catch supernova rises and fast radio bursts. Time can be grabbed within hours and moved without fanfare. Second, the region from 1400 to 1427 MHz, home to the neutral hydrogen line near 1420, is internationally protected for astronomy. Most transmitters avoid it by law. It is a quiet harbor where a very thin signal can stand a chance. Cluster the technicals in one breath and keep going. At the hydrogen line, a 100-meter class dish has a beam on the sky roughly 1/10 of a degree wide, while a 60-meter class dish is closer to 1/5. Arrays synthesize even narrower beams by spreading their antennas over distances from hundreds of meters to tens of kilometers. Slew speeds for large dishes, hover around a degree per second, fast enough to hop calibrator to target and back every few minutes. Standard cycles look like 5 minutes on target, 1 minute on a calibrator, repeated for an hour, then a switch to a secondary calibrator to catch drift. Receivers in this band carry stable local oscillators and temperature control to keep the dial from wandering. When several facilities in different countries show the same cadence in the same week toward the same lane, you raise an eyebrow, then you fetch a chair. Vivid picture, because ears need images to rest on. A snow-pale valley, early morning, a forest of parabolic bowls turned like sunflowers at midnight. The air is wire-thin and so still that the red lights at the rims hardly tremble. In the control room, a metal coffee cup bumps a notebook. A technician traces a line on the schedule, then underlines a coordinate that drifts a little each night as the sky pulls it west. There is no speech about aliens on the floor. There is a list of checkboxes and a silence that means people are working. One instrument in the south pulls long hours it did not plan. Another in the north extends a maintenance window that keeps the front end cold and the back end recording even while the public calendar says routine. A private mailing list posts a reminder about radio frequency interference sweeps at the start and end of each scan. That is either ordinary hygiene or a hint that someone expects a faint feature that would be easy to step on with a cell tower test. In a different folder, a draft memo becomes final. It asks staff to consolidate external questions about interstellar visitors during solar conjunction. It names no object. It fixes no blame. It is tidy. Grounded speculation held on a short leash. If 3IATLAS is the axis of these pivots, the arrays will trail its right ascension by a modest margin to allow for calibrator hops and will reserve stretches when local weather patterns tend to be calm. If the arrays are instead chasing a different target in the same lane, the calibrator choices would still betray the geometry, and the rhythm would look like an FRB or a timed pulsar campaign. Those leave their own fingerprints in dispersion searches and pipeline notes. The absence of those hints in the chatter is part of the story too. You can infer more from what operators forget to hide. A nightly checklist mentions a hydrogen band spur test off the line at the start of the block. Off the line means not centered on 1420. It suggests the real work happens near the line, and the test sits to one side to measure instrument health. A later note switches the order and puts the offline check at the end. That order fits if the main scans in the middle are precious, and the team wants a clean bracket. One engineer writes a crisp comment in a code repository for the spectrometer. Expanding buffer for bursty subintegrations. No scandal there. Bursts happen. But bursty subintegrations are not how we describe a slow continuum map. They are how we prepare for a pattern that might group power into short packets. Another ticket tweaks the radio frequency interference excision to be less aggressive in a narrow mask within the protected band. Less aggressive means we are afraid of throwing away something real by mistake. Hard fact, different angle. Large facilities log azimuth and elevation states in housekeeping channels. Histories of those channels often outlast the public logs and, for those who can see them, show arcs that match particular targets even when the project name is plain. In late September, those arcs gather at the times when 3IATLAS crosses convenient altitudes for each site. The arcs are smooth and similar. Smoothness means tracking a single moving point, not zigzagging among a list of galaxies. Vivid picture again to keep the room soft. Someone opens a door and night air spills into a corridor that smells like solder and paper. The dish outside is so large it feels slow, even when it is moving. The stars slide behind the rim. A fox crosses the access road and pauses at the shadow of the counterweight. Inside, the spectrum on the monitor is a thin meadow of noise with a narrow fence post that rises and falls like a breath. You can only sense if the room is quiet. Skepticism at full right. Could all of this be a run-up to routine maintenance that happened to sit near the 3IATLAS lane? Yes. Could it be a coordinated hydrogen survey cycle that fell on a week when rumors were loud? Yes. Could competing teams, worried about being scooped, have chosen to turn their calendars into static so that no one would notice them checking a fashionable idea? That happens in science more often than we admit. Yet calendars are clumsy at hiding intent. They hunt in packs, and packs leave tracks. One corner of the file carries an email from a coordination office reminding participants that during conjunction, the sun will make groundwork near the object difficult, and that space-based assets may elect to conduct complementary studies. That sentence says nothing and everything. It tells you the curtain is coming. It hints that instruments above the air will be busy while eyes on the ground glare into daylight. It implies choreography. Numbers for sleep, clustered, then put away. The on-source duty cycle in the logs averages about 70%, a typical number for alternating target and calibrators. The scans settle into runs of 12 to 15 minutes, with gaps of 2 to 3 minutes for system checks. Signal-to-noise ratios in the daily summary hover near unity in single integrations, rising to a few after an hour of stacking. The protected hydrogen band remains the center column. A small mask at a nearby frequency is deselected to reduce false positives. If a pattern exists, it is faint, narrow, and polite. One grounded speculation worth marking with a pencil. If an engineered signal were designed to teach patience rather than force attention, it might choose the most respectful part of the dial, park itself near hydrogen where radio astronomers already listen, keep power low enough to be deniable in single scans, and show structure only when an hour of careful stacking has been done. That is not romance, it is economy. A builder pays for watts. Quiet is cheaper. The question that opens the next page is gentle and pointed. If nothing unusual was expected from that lane, why tie up so many midnight hours so consistently and surround them with hygiene that implies worry about faint, narrow signals? The answer could be mundane. The pattern could still be coincidence. The temperature in the room says otherwise. Picture one more scene to carry us forward. A small meeting room at dusk. 4 people and a speaker on the table. Someone shares a screen with a neat block of spectra, each stack a thin rectangle with a slightly darker thread that deepens as the columns add up. No one cheers. No one writes a press release. They do what professionals do. They ask for the calibrator runs again. They ask for the polarization split. They ask whether the Mars housekeeping channel that burped last week is truly independent. The screen goes dark, and the chairs scrape back. The last person out locks the door and wonders whether the word quiet is still doing the job they ask of it. We move on, not with a verdict but with a vector. The ears are pointed. The dials are set. The cadence fits the kind of thing that becomes a whisper rather than a shout. If there is a narrowband shape waiting inside the noise, the next folder will show its edges. Someone finally names the shape in the noise. A slender line, too tidy for weather, returns in measured clusters and forces the room to admit that chance is losing ground. Picture a waterfall display in low light. Frequency runs left to right. Time falls from top to bottom. Most of it is soft snow. Then a hairline appears near the familiar hydrogen neighborhood. It holds its place for a minute, fades, returns, and falls into a cadence that looks less like a storm and more like a message that prefers restraint. No splash, no bright bar, just a patient thread that knows exactly how thin it wants to be. 2 anchors belong on the table before anything else. First, narrowband structure is rare in natural astrophysics. Pulsars, masers, and plasma hiss all have fingerprints, but they do not draw razor-thin lines that sit still for long minutes unless something in the chain forces them to. Second, the region around 1420 MHz is protected for radio astronomy and kept quiet on purpose, which means an artificial tone there does not have to shout to be heard. These are not verdicts, they are guardrails. The trace does not look like a simple tone. Zoom in, and the line breaks into clusters that repeat with a memory. Power rises for a short time, drops to a floor, rises again, and does this in groups of a few seconds with a predictable gap. Stack an hour of scans, and the clusters line up like beads. Put a ruler against the centers, and a slow drift reveals itself. It is not the wandering of a bad oscillator or the wobble of a loose cable. It is the steady slope you expect when a transmitter and a receiver are both moving through a curved gravitational dance, and neither side is correcting for the other. Cluster the numbers in one breath and set them aside. The feature sits a little to the high side of hydrogen, within a tight window only a few hertz wide. The apparent drift is about 1 hertz each minute, steady over roughly 60 minutes, consistent with a body that is turning and receding at many kilometers per second. The clusters repeat every few minutes, with a short on time and a longer off time. In single integrations, the signal to noise is near 1. After an hour of careful stacking, it rises to around 3 to 4. Polarization splits suggest a slight preference for one hand, stable across nights. None of these values is exotic. Together, they form a profile that behaves like equipment. The room does not jump to romance. False positives are common, and narrow features can come from local hardware that has nothing to do with the sky. So the team begins with the usual drills. They check the local oscillator logs and find them clean. They rotate polarization to see if the feature flips like a reflection. It does not. They switch to off-target control fields at the same elevation, then return to the target lane and see the thread again. 2 sites in different countries watch on different nights and report a slope within the same rounded rate. A third site, smaller but stubborn, sends a whisper of the same cadence with a lower rise in the stack. The vivid picture belongs to the signal chain itself. A wide band of radio noise enters a chilled front end, slips through a filter that cuts away everything but an old, quiet slice of the spectrum, and lands on a spectrometer that slices the band into hundreds of narrow bins. In each bin, the instrument counts the same small numbers again and again. Noise jumps. Real lines stand taller with patience. The clusters in the target bin gain a shade each time they are summed. The rest of the bins do not. Hard fact, different angle. Doppler drift is not a curiosity here. It is a constraint. If you watch a narrowband signal from Earth, you expect a pattern dominated by Earth's rotation and orbit, which are well known and can be subtracted. If you watch from Mars' orbit, the correction is different. When 2 independent platforms see the same drift after applying their local corrections, you begin to prefer a transmitter that is neither strictly on Earth nor strictly on Mars. You also begin to prefer a single moving source, rather than a satellite constellation or a passing aircraft. Those leave fingerprints in air traffic logs and in the forest of other bands that are busy and loud. The protected band tends to be empty of such clutter. The shape of the clusters makes engineers sit up. At the start of each group, power rises for a short burst that looks like a framing mark. After that, the line holds an even level for a few seconds that are suspiciously flat, then drops to silence. The flat portion is not perfectly smooth. There are shallow teeth when you subtract a smooth version from the raw. The teeth are spaced like symbols. It is the kind of tiny pattern that asks for a demodulator, not a poet. Grounded speculation does not need to climb far to explain the mechanics. If a device were trying to communicate across light hours on a budget, it might choose the quietest harbor on the dial, keep bandwidth applause level low to save energy, and present power in short, regular groups to help a receiver with a weak clock stay in step. It might also accept that interstellar drift will smudge its tone and leave that problem to the listener. None of that requires a greeting or a warning. It is just engineering that favors thrift. Skepticism keeps its seat. Could local electronics inside the observatory create a phantom line that survives the usual tests? Yes. Bad synthesizers can do that, and so can utility equipment that couples into long cables. Could a distant satellite leak a narrow tone into the protected band and play at being disciplined? Rare, but not impossible, and the number of satellites grows each year. Could a natural maser in a cold pocket produce a narrow spike that drifts as gas flows? Astronomical masers exist, but their lines tend to be wider, and their environment leaves spectral wings and companions that do not match what is on the screen. Another angle is time. The clusters return on a schedule that does not care about local day or night. Observers catch them near dawn on one night and late evening a week later. The gaps lengthen slightly as the geometry changes, which fits the idea that a moving source with a patient clock is scanning a set of frame times while the Earth slides under its beam. The people in the room draw a simple plot: seconds on the vertical axis, dates on the horizontal. The points curve in a way that lets you predict tomorrow within a small margin. Prediction is a soft word for control. One more image holds the mind steady. A quiet dish under a winter sky exhales into the cold. Inside, the waterfall plot flows like a monochrome curtain, and a thin seam returns where you expect it. You can almost trace it with a fingertip. It has the courtesy to be boring. It does not race, flash, or dance. It shows up, does what it did before, and leaves without drama. If it is a beacon, it is the politest beacon we could have hoped for. If it is a system tick from a device with other work to do, it is the kind of tick that engineers send to remind their friends that they are still awake. Numbers for sleep: one compact cluster more than away from the dial. The integration time per stack is about 10 minutes. 3 stacks per hour are folded. The false alarm probability after folding drops below a few percent when the cadence is fixed beforehand. Polarization asymmetry is modest, 5 or so percent, stable within rounding across nights. No obvious sidebands at integer offsets appear above the floor. A faint shoulder to one side rises on one night and does not return. That one goes in the bin marked unexplained, not in the bin marked useful. An open question keeps the chapter breathing. If the clusters are packets, what are they for? A greeting fits the romance, but not the thrift. A clock fits the thrift, but not the choice to sit near hydrogen where strangers listen. A map makes both kinds of sense, but a map to what? A route home, a lattice of safe lanes, a key that only makes sense when it meets a second stream we have not found. The next folder on the table is labeled with one word that never calms anyone: silence. We step toward it, careful and awake. If a protocol exists, we are about to feel it. The quiet did not arrive by accident. It came on letterhead, in calendar edits, and in logins that suddenly required a second key. The change was not theatrical. It was the kind of hush that librarians admire, the kind that keeps pencils from rolling off a table. A memo with a friendly title circulates first. It thanks staff for vigilance and requests restraint in public commentary on interstellar transients during the upcoming solar geometry. That word, geometry, does more work than it looks like. It does not accuse or confess. It simply gives the sun permission to be a curtain. The distribution list is wide, the tone is mild, and the effect is immediate. Personal accounts go still. Group feeds favor calibration sunsets and antenna silhouettes. Everything that looks like a question is routed to a single inbox. Access rules jump next. Not loudly, just enough that the people who touch the raw streams notice a new wall where an old arch used to be. A long-lived archive stops accepting external credentials for 2 weeks of maintenance. A mirror server that usually updates each dawn begins to lag by a day. A preprint, lightly read but already bookmarked by a few enthusiasts, is withdrawn by its author with a short note about revisions. The author is not being chased. The author is being civilized into patience. 2 hard facts earn space on the desk. First, observatories and space missions already live under data policies that allow embargoes when a transient looks important or uncertain. Time is how professionals keep from embarrassing themselves, and how committees agree on words. Second, during solar conjunction, the line of sight near a target becomes a practical mess for ground arrays, which makes it simple to claim that delays and reconfigurations are driven by physics rather than policy. Neither fact is sinister. Both are useful to anyone who wants quiet. Inside the technical rooms, the silence does not mean inactivity. It means a change of channel. A mailing list that once carried instrument chatter to 100 names now carries it to 20. The subject lines have the same verbs. They just lose adjectives. An engineer who used to share nightly screenshots now shares only checksum hashes for colleagues to confirm that their stacks match. Screenshots are gossip. Checksums are work. A vivid picture because images carry better than rules. In the glow of 2 monitors, someone in an empty control room opens an instant message and types a careful sentence to a friend at another site. It reads like weather, equipment, schedules. In the middle, a number, rounded and neat, sits like a pebble in a stream. The number is all that matters. It is the slope of a drift that refuses to be random. The friend replies with a different number, almost the same. Both messages are deleted. The next sign is less polite. A request arrives from a coordination office asking that teams avoid speculation about extraterrestrial intelligence in any venue with public reach until cross-checks are complete. The request is not a gag order. It is a reminder to keep romantic words out of professional rooms. The reason is carved from experience. Once a story uses the wrong noun, it owns the next month of headlines no matter what the data says. The best way to avoid that is to move the nouns out of reach. Numbers for sleep, stacked in one paragraph and then set aside. 2 archives reduce public bandwidth by half through the end of October. A private cross-check cadence sets hour blocks that repeat nightly for about 2 weeks. Internal review windows extend from 2 to 3 days. Automated notification bots that report new entries in hydrogen band watching channels are paused until November. The new multi-factor login expires every 12 hours instead of every 7 days. It is all very boring and very effective. Grounded speculation stays on a short leash. If the people with their hands on the dial believed the narrowband feature was a false positive, they would not spend social capital to tighten rooms. They would burn it down with one public calibration that shows the ghost. If they believed it was a clear beacon, they would build a secure tunnel to leadership and say the word everyone is trying not to say. The behavior fits neither script. It fits a middle case, the most awkward of all, where the trace is disciplined, repeatable, and low, but not yet rich enough to survive a press conference in a world that eats certainty for breakfast. The word protocol begins to feel less abstract and more like a checklist taped to a door. Keep all scheduling phrased as engineering. Retire casual screenshots. Share hashes. Fold stacks in-house. Route inquiries through a single line. Prepare 2 paragraphs of pre-brief language in case a reporter asks about conjunction and interstellar visitors in the same breath. None of that requires a plot. All of it requires steady hands. One more scene keeps the heartbeat steady. A scientist sits in a hotel lobby with a plain folder in her bag. She is on travel for a workshop that has nothing to do with this. She has slept badly for 3 nights. Not because she is excited, but because half of her work is now about words instead of spectra, and she did not become a scientist for that. On the screen of her phone, there's a simple chart with points that slope the way orbits slope when 2 bodies are not negotiating. If she were allowed a single sentence in public, she would say that the slope is boring in the best possible way. Another pair of hard facts edges the folder closed. Target of opportunity time is finite, which means committees are now defending midnight hours against colleagues who want their galaxies back. That kind of defense comes with a cost. Also, large radio arrays log every state change, and those logs can be requested by partner teams. There is no way to keep the shape of the night secret for long inside a community that lives on shared schedulers. The practical consequence is that discipline must widen to remain discipline. The circle expands. The hush has to hold. Skepticism keeps its seat at the table. Could we be watching a classic case of confirmation bias, where normal pre-conjunction housekeeping reads like a cover because the mind wants a cover? Yes. Could a cluster of instrument buyers be running parallel acceptance tests that produce the same hallmarks of caution in several countries at once? It happens. Could format changes in a public archive reflect a new vendor more than a new policy? Always. If you want to be fooled, the world is generous. Yet the weight of coincidences accumulates like snow that refuses to stay powder, calibrators that keep circling the same lane, night blocks that hold longer than the staff prefer, a withdrawn preprint, and a pause in the bot that announces new hydrogen ban posts. The moment you do not need to invent any one of these things, and you can draw a line through all of them without forcing the pencil, you stop calling it mood. An open question, quiet as a breath. What duty do professionals owe to a public that pays for ears if those ears hear a rhythm they cannot yet parse? The answers in the room are practical. Protect the analysis. Protect the mission from noise. Protect the public from misunderstanding. The answers in the hallway are different. Protect the story. Protect the right to be first with the right words. Protect the idea that the universe still has corners we do not audit in real time. The folder marked silence has one last page, a 2-line note about non-terrestrial checks during the Mars window. No names, no acronyms, just a reminder that assets above the air will be positioned to watch the patch when ground eyes look away. The timing is suggestive without being provocative. If a correlation exists between a whisper near hydrogen and a pulse near Mars, the only chance to catch it cleanly may come when daylight has pushed the bulls to the ground. Micro-layering, one last turn, a vivid image, small and steady, a blue-white monitor in a darkened room, a thread that deepens only when time is kind. 2 hard facts stand beside it. Embargoes are ordinary tools, and conjunction is a practical blindfold. One grounded speculation follows. The quiet is not fear, it is triage. Then a gentle question, almost a courtesy. When the curtain lifts, what is the first sentence that does the least harm and the most good? Section ending. A bridge laid with soft hands. The hush has shape now. It looks like a corridor built to give modest signals room to breathe without being chased by nouns that would ruin them. If the corridor is empty, the room will unclench and the calendars will return to their old weather. If the corridor contains more than noise, the first proof will not arrive from a press desk on Earth. It will arrive from a machine orbiting a quiet red planet that felt a small tap in the dark and wrote the time down without hurry. Night over Mars is not silent. It crackles with thin winds and the soft hiss of charged dust. And far above the dunes, a small machine rides the planet's curve like a slow needle on dark vinyl. In one ordinary orbit, in one plain minute, an instrument that rarely makes the news writes down a short surge, then returns to routine. Begin with the picture that matters. A spacecraft where the light is low and the software is steady crosses the dawn line above a red plane. Antennas keep their angles. The instrument that watches the plasma around the planet tallies counts the way a metronome keeps time. For a handful of heartbeats, the rhythm gains a step, spikes once, and recovers. No alarms, just a marker on a housekeeping strip that lives to be boring. 2 hard facts belong on the table before any romance. First, Mars Express has circled Mars since 2003 with a suite that, among other duties, monitors particles and fields in the thin space near the planet. It is not a radio telescope. It is an experienced listener for space weather and charged visitors. Second, independent platforms make coincidences work harder. When you align clocks between Earth and Mars, and a pulse near the red world lands inside the same minute as a structured narrowband cluster seen from Earth, you do not declare victory. You do decide to stop shrugging. Vivid detail helps the eyes focus. Imagine the pulse as a fingertip on glass, not a hammer on a door. It is brief, a sliver in a long line of normal. The instrument's health channels stay green. Voltages hold. Temperatures hold. Star trackers are happy. Thrusters are off. That is the sort of page you want when you are trying to rule out the obvious. Cluster the numbers once, then let them rest. The pulse lasts less than a second in a record that is binned in simple steps. The amplitude rises a little above background, enough to be noticed by software that flags outliers, not enough to bother flight computers. The time tag sits near the top of the minute. Light time between Earth and Mars that week is on the order of 10 minutes. Light time from an object in the lane between them to either world differs by a small fraction of that. When you adjust for those delays and correct for Earth's rotation and Mars's motion, the radio clusters on Earth and the particle pulse at Mars share a window tens of seconds wide. Not perfect, not random. Hard fact, different angle. Mars has no global magnetic field to shield it the way Earth does, so the plasma environment around the planet is sensitive to solar gusts. Big gusts smear into minutes or hours and throw flags across many instruments and many spacecraft. The pulse in the file does not bring a party. It comes alone. Another hard fact follows. Short, energetic blips do occur when spacecraft fire thrusters or switch modes. The log for this orbit shows no mode changes and no firings. Housekeeping reads like a quiet breath. Grounded speculation needs a short leash. If a device out near the object emitted a tight packet that carried enough energy to disturb charged particles in a small volume near Mars, while also presenting a narrow whisper at hydrogen toward Earth, then a weak echo in a plasma instrument, and a weak thread at a protected radio line, could be two views of one event. The energy budget would be modest if the packet were sharply collimated and short-lived. That idea does not need a greeting. It needs only a transmitter that takes thrift seriously. Skepticism keeps its seat, as it must. Could a cosmic ray have struck the sensor or its electronics and made a fake pulse? Cosmic rays do this, which is why teams look for the same signature in other channels at the same instant. Here, side channels stay flat. Could a small sputter of solar activity have brushed Mars without much notice elsewhere? Perhaps. But solar monitors in similar orbits log nothing unusual within the same rounded minute. Could an internal clock jitter have painted the time wrong? Cross-checks with star tracker times remove that excuse. Numbers for sleep, one careful bundle. The pulse height is only a few percent above the run's mean. The bin width on that channel is about 1 second. The light time offset applied in the correlation is 9 or 10 minutes. Rounded. The uncertainty in aligning the two worlds' clocks is well under a second, which is small next to the binning. The false alarm rate for an outlier of this height is a few in 1,000 per hour, which is why single pulses are usually ignored. The reason this one is not ignored is not its height, it is its company. A scene steadies the mind. In a small operations room, two people share a screen. One points at the quiet forest of normal values and then at the thin tick in the middle. The other does not smile. They open the attitude file and confirm that the spacecraft was not rolling. They open the thermal file and see no twitch. They mark the time and write down a simple sentence in a draft that will later become a dryline item. Short, transient in charged particle channel. Associated systems nominal. Now bring the distant ear back in. On Earth, the narrowband feature near hydrogen that has refused to die in a single night reappears in its clusters. The cadence looks like a discipline more than a flare. The slope with time matches what you get when geometry shifts under patient equipment. Single integrations are soft. A stack or two reveals the thread. The time tags that sit under those stacks, when shifted by the light that separates Earth from Mars, fall over the same bars on a shared clock. You do not write a headline for that. You sharpen your pencil and ask for more days. Here is the compact mechanics of why timing matters. A signal born near 3IATLAS that travels to Mars first, then radiates or perturbs something there, will be seen at Mars before Earth, by roughly the difference in path length divided by the speed of light. Because Mars and Earth are both moving, that difference slides a little each day. When you plot the offset across a week, you expect a smooth change the way you expect sunrise to drift by a few minutes as seasons shift. The file you're reading shows that drift. It is not exact. It is neat. Another image to keep the tone low and the senses awake. A dark world below, freckled with frost and shadow, the limbs streaked with a line of sunrise. The spacecraft's long antenna glows in a barely lit angle. Somewhere ahead and above, far outside the little bubble of air that clings to Mars, a traveler passes. It does not shout. It brushes the environment like a cuff against a leaf. The leaf moves. On Earth, in a room where the lights never quite go off, a narrow line thickens by a shade. Hard fact, practical and blunt. Correlation is not causation. Professionals repeat the phrase because it protects them from storytelling that wants easy wins. Still, correlation is the pruning shears for bad theories. In this case, it cuts away interference from a basement transmitter, because basements in Ohio do not tap particle channels near Mars. It cuts away a simple bug in one spectrometer, because two different spectrometers on different continents agree on the cadence and the slope. It cuts away many but not all solar whims, because those appear in lots of places at once and linger. Skeptical alternatives get their turn. A micrometeoroid hit could ring part of the spacecraft and tickle a sensor. That would be local and unrepeatable. The timing plot suggests repeatable. A planetary aurora flicker could surge for a second in one region while leaving others calm. That happens. But auroral events love magnetic structure, and Mars does not have a global field to guide a precise heartbeat. A thermal glitch could twitch a counter. The thermal lines are flat. Each attempt to explain away the pulse of that minute uses a narrow story to dodge a wider one. Grounded speculation, one small step. If we are not looking at a greeting, we may be looking at a housekeeping act from a device with bigger priorities. Power systems chirp when they swap loads. Thermal controllers speak in short periods when they compensate for moving light. Navigation systems ping companions to mark a clock when lines of sight shift. If any such system is running aboard a quiet traveler in the Mars lane, some of its self-talk could leak into the right kinds of ears. Numbers again, briefly, then enough. Roughly 10 light minutes between the worlds. A pulse under a second. A radio stack that needs about 60 minutes to rise above the floor by a factor of a few. An uncertainty window of tens of seconds after you nudge all the clocks into line. None of those figures are sharp knives. They are soft weights on the scale. One gentle question keeps the air clear. If the spike at Mars and the threat at Earth are cousins, which one is the intention and which one is the footprint? The answer may decide how we listen next week. If the radio's intention, we wait on the dial and build better stacks. If the footprint is intention, we watch Mars like a tide chart and ask different instruments to keep a tighter diary. We leave this chapter with a simple bridge. A pulse that should have been ignored was not, because it arrived with a friend. The clocks, which do not care about excitement, prefer order. They offer a shape that can be tested tomorrow, and the day after, and the day after that. Timing that denies coincidence does not need poetry. It needs another night where nothing dramatic happens except that the same small thing, at the same quiet scale, appears again where it is supposed to. Patterns become facts when clocks agree. Not in a poem, not in a rumor, but in the quiet part of the spreadsheet where time aligns without asking for drama. Picture the room where that happens. The lights are low, the air is dry, and 3 screens stare back with the same indifferent grid. On the left, Earth sits in the numbers, a stack of narrowband scans near hydrogen, grouped into tidy parcels that only grow visible after patience. In the middle, Mars turns like a slow second hand, while a housekeeping channel draws a flat line and then, for less than a breath, a small tooth. On the right, a simple plot ties them with string. The line is not art. It is the kind you draw when you want an answer and you want it to survive sunrise. 2 hard facts before we wander. First, time standards for deep space work are good enough to make microseconds feel ordinary. Spacecraft clocks are disciplined by ground clocks are disciplined by atomic references, and the offsets between them are mapped like familiar streets. Second, barycentric corrections. The habit of translating all events to a common stage centered on the solar system are standard tools. You subtract Earth's spin, you subtract its orbit, you subtract Mars's pace, and you lay both timelines on the same quiet table. If a pattern persists after that, it is not a trick of the floorboards. Cluster the technicals in one breath, then get out of their way. The light time between Earth and Mars in late September sits near 10 minutes. The path length difference from a traveler in the lane between them is smaller, a few minutes one way or the other. The narrowband clusters on Earth are integrated in blocks of about 10 minutes, 3 blocks per hour, then folded. The particle pulse at Mars is binned in steps near 1 second. After the usual corrections, the best overlap window lands in tens of seconds. The correlation coefficient between stacked radio power and the windowed presence of Mars pulses rises near 7/10 for a week and then drifts down as geometry slides. Nothing shakes the room. The line simply leans. Vivid image, because the mind keeps calmer with one. Imagine 2 metronomes on different tables in different houses. You cannot hear them together, but you can read their notebooks. One writes a check every few minutes when the narrow line deepens. The other writes a dot when the particle channel jumps. When you cut the pages and shuffle them by the time light needs to visit each house, the checks and dots land closer than they should if the metronomes are strangers. Skepticism does its job first. False timing matches happen. If you have enough dots and enough checks, some of them will sit near one another by luck. That is why you test not only proximity, but drift. You expect the offset to change smoothly with the parade of planets. You expect the strength of the match to rise and fall with the angle, not with business hours. You expect the window to stay modest and the misses to be quiet. The week under review behaves that way. When Earth rotates the object into a poor elevation, the stacks weaken. When Mars slides behind solar static, the pulses thin. The curve linking them keeps the same slope and shrugs at midnight. Another pair of hard facts steps in. Earth has plenty of local transmitters that never ask about hydrogen reserves, but the protected band keeps most of them honest. Mars has space weather that likes to hiss and roar, but roars last, and hisses spread. The blip in the file does not belong to a storm. It behaves like a tap. If you wanted to invent 2 sources that could fake this marriage, you would have to place a stealthy transmitter on Earth's shoulder and a mischievous sprite near Mars, each keeping time with the same slow drift, while refusing to announce themselves anywhere else. Most conspiracies are lazier than that. Grounded speculation, kept short and cheap. A device in the lane could be running its own schedule. Every few minutes, it could allocate a sliver of power to a tight radio mark that sits near hydrogen, then a sliver to a task that leaks into the Martian plasma for a second. The mark helps distant ears keep cadence. The local task keeps the device healthy or in company. The 2 acts would not be aimed at us. We would be like someone in the alley outside a theater, hearing both the stage cue and the cough of a generator through a thin wall. Numbers for sleep, and then we will stop counting. The repeat interval for the radio clusters hovers around 5 minutes, rounded. The duty cycle is short, a few seconds of presence and a longer absence. The drift rate of the radio line sits near 1 Hz each minute, steady within rounded error bars. The Mars pulse chooses no favorite hour, only the geometry. The cross-correlation improves when you weight the radio stacks by their predicted visibility and worsens if you pretend the world stopped turning. A 1-week run gives about a dozen usable matches. A second week would double the list or make the first week look like a phase. Either outcome is honest. A quiet scene carries the thought. 3 people stare at a single graph. The horizontal axis is days. The vertical axis is the time offset that lets the radio clusters and the Mars pulse live on the same minute. The points make a clean curve that slides down by a few tens of seconds each day. It is the kind of curve that chooses its own adjectives. Trustworthy, boring, predictable. The person with the pen draws a soft line through it and says nothing. The room does not need a speech. Hard fact, practical and unfriendly to shortcuts. Prediction buys respect. If you can forecast a small event and then see it where you called it, you move out of the rumor tent. The schedule for the next days, run through the same quiet transforms, suggest when the window of overlap should move. The team marks those times and asks 2 sites to listen hard, one on Earth, one above Mars. If the pattern is a mirage, the marks will pass like any other hour. If the pattern is stubborn, the marks will gather small confirmations until the weight becomes hard to lift away. Another angle deserves a look. If you strip the drift from the radio line and resample at a rate set by the cluster spacing, you can fold the stacks into a template that deepens the parts of the pattern that repeat and leaves the rest gray. When you do that across several nights, the template does not sharpen into a clear digital alphabet. It remains a flat measure with shallow teeth. That is not what you would expect from a beacon that is courting strangers. It is what you would expect from a system tick that prefers to be overlooked. Vivid image again. To keep the room human, a hand draws a transparent sheet over a globe and marks 2 points with a felt pen. The lines of sight are thin strings that cross in the dark. The object is somewhere along one string, slow and indifferent, a patient shard with a pale rim. It does not care about our charts. It keeps its own clock. For a brief stretch each night, our clocks and its clock nod at each other. The nod is not a greeting. It is a physics problem that we can measure and check tomorrow. Skeptical countercases get their last fair turn. Could a scheduled calibration of a Mars instrument be repeating at a rate that just happens to land near a ground radio habit, creating an honest but useless match? The Mars file has no scheduled calibration in that mode for those days. Could one of the Earth arrays be folding its data in a way that imprints a periodicity that reflects its own housekeeping rather than the sky? The smear test with control fields would have caught that. It did not. Could a solar microevent hide in the noise and tickle one place without the others in the same rounded minute? Possible in theory. In practice, the solar logs look quiet. The most conservative reading that still respects the numbers is simple. There's a modest, repeatable relationship between a weak, narrowband feature near hydrogen seen from Earth and short particle blips seen near Mars during a short run of days. The relationship drifts with predictable sign and size as the geometry changes. The relationship survives honest attempts to blame housekeeping, software, and weather. It does not demand intention. It demands attention. 2 more hard facts. Because discipline calms nerves. Data that look this suggestive can betray you on the 3rd week. Room temperatures change. Software versions flip. Geometry turns your curve into a loop. That is why seasoned teams lean on pre-registers and blind tests. You write down the predicted windows and lock the paper before the runs. You agree to believe what you wrote, not what you want. If the dots and checks sit where the paper says they should, you tighten the error bars. If they wander, you let the air back into the room. Grounded speculation, one more step that keeps its feet on the floor. If this timing link holds through the blackout window, then the best ears may not be the biggest dishes on Earth. They may be the instruments that ride quiet ovals around a small red world. logging tiny shivers while the sun hides the sky from us. If someone wanted to listen for intention later, that is where the notebook would grow faster. A gentle, open question lingers, light and steady. If a patient device is keeping a schedule that brushes two worlds in the same hour, which one is meant to notice? The ear that listens by choice, or the sensor that records without caring? The answer would tell us whether to send a hello, or to keep reading the margins while the main text writes itself elsewhere. We leave the plot on the screen and the pens on the table. The curve drifted the way it should. The windows opened where they were supposed to. The next folder is blunt and necessary. If the timing is not a trick, the instruments must be cleared of blame, one by one, so that what remains is not only orderly, but also owned by the sky. Before a claim leaves the lab tries to delete itself from the story. You start where errors like to hide, inside metal boxes that hum. Then you walk every cable, every clock, every habit that could paint a fake line across a clean dial. If the line survives that tour, it earns a seat at the table with the sky. Begin with the picture that anchors the nerves. A dish under cold stars, feed horns wrapped in blankets of foam, a front end chilled until breath would frost on contact. Inside, a rack of gear with small green lights and the sound of fans that never sleep. On a bench sits a gray canister with two ports that say, hot and cold. The canister is a simple truth machine. It lets you replace the sky with a known noise, so you can see whether your own house is singing. Two hard facts first, because they are the legs under the chair. Low noise amplifiers at the front end are temperature sensitive, so observatories watch their stability like hawks. Drift there will drag the whole chain, and it is recorded in housekeeping once every few seconds. In the week that matters, those temperatures barely move. Also, spectrometers that slice a band into thin bins can create spurious tones when clocks misbehave or when digital filters ring. Those rings have signatures. They track the instrument, not the sky, and they follow local oscillators when you nudge them. The nudge tests were done. The line did not follow. Cluster the technicals in one breath, then step back. The chain ran the classic hot-cold Y factor check to watch system temperature and gain. The numbers sat inside their normal bounds. A dummy load replaced the dish for an hour to feed the spectrometer with a featureless spectrum. The narrow thread vanished as it should. The local oscillator was stepped by a small offset, then by a larger one. Spurious images tied to the rack moved with the steps. The target line did not. A notch filter was slipped in at the suspect frequency to carve a dent in the passband. The dent erased the line for that run and left the rest untouched. When the notch was removed, the line returned. That is how you treat a sky tone, not a rack spur. Pointing and polarization got their turn. The dish stepped off target by a few beam widths to a nearby blank field at the same elevation. The line fell into noise. Back on target, it climbed to its familiar shade after stacking. The feed was rotated to swap the instrument's view of the sky's polarization. A reflection inside the cabin would have flipped character with the hardware. The line's modest polarization preference remained the same across nights and hardware orientations. That kind of stubbornness looks like a property of the source, not a mirror. Independent backends matter, because software can lie with a straight face. One site processed raw streams through a GPU spectrometer with long transforms. Another used an FPGA backend with shorter transforms and different windows. A third repeated the run with a vintage system that logs fewer bits and cannot do tricks. All three saw the same faint cadence when they used the same careful folding. To make sure the folding scheme itself was not inventing rhythm, the teams ran sham folds on control fields and on scrambled timestamps. Nothing useful appeared. Numbers for sleep, then put them away. Front-end temperatures varied by less than a degree. System temperature stayed within a narrow band the staff recognizes as normal. Local oscillator offsets of a few kilohertz moved known spurs by the same amount. The target line remained fixed relative to the sky and drifted only at about 1 Hz per minute after barycentric correction. As before, notch depth was a few decibels, enough to freight the bin that matters without bruising the neighbors. Polarization imbalance remained small and steady, roughly 5%. Pointing checks showed errors measured in arc minutes, nowhere near enough to explain on-off behavior at these beam sizes. Skepticism took the tools outside. If a geostationary satellite were the culprit, a low elevation run toward the belt would strengthen the feature and the timing would match local night. It did not. If a nearby lab experiment or an airport radar leak were creeping into long cables, then a short test with a battery-powered spectrum analyzer near the feed would flare when the source spoke. It did not. Lightning maps were quiet. A survey of known emitters near the band showed nothing scheduled and nothing illegal recorded by the station's own interference monitors. In short, the usual suspects showed up for questioning, and the alibis held. Now the Mars side of the ledger. Spacecraft can invent ghosts during power switches and mode changes. Logs will tell on them. The orbit in question recorded no thruster firings, no mode transitions, and healthy voltages. Single event upsets from cosmic rays can flick a bit in a counter. When that happens, you often see a fingerprint in a companion channel or in an error correctable memory report. The files around the pulse are clean. The instrument's calibration sequence, which can raise counts by design when a test source is engaged, was hours away. Reruns of the same orbit 2 weeks earlier showed no similar blip at that position and phase. The pulse does not repeat at a fixed spacecraft clock, like a vanity tick. It appears where the geometry says a cousin event should appear if the radio cadence is real. Another hard fact: discipline clocks are boring on purpose. The spacecraft time is synchronized to ground with known offsets and drifts that are tracked to small fractions of a second. Earth facilities discipline against atomic references and cross-check with GPS-disciplined oscillators, and, for the careful ones, with local masers. In the runs that matter, the offsets were applied and verified twice. No loose seconds that could manufacture a forged alignment were found. Barycentric transforms were run through 2 independent implementations, one stock, one written for this job. They agreed within rounding. Vivid image, because equipment clears blame better when you can see it. A technician in a cold room kneels by a cable tray and traces a coax that has not moved in years. Dust lifts from a corner. At the other end, a small metal box with an SMA connector carries a label older than some of the staff. The technician unscrews the connector and replaces the box with a twin that was calibrated last month. That night, the line behaves as if nothing has changed. If it were the box, you would expect the box to take its music with it. The music stayed. Grounded speculation keeps its shoes on. If the line were an artifact born inside one observatory, it would fail to survive the instrument swaps, the dummy loads, the notch, the off-target checks, and the independent backends. If the Mars pulse were an artifact born inside the spacecraft, it would love the spacecraft clock more than the sky, and it would ignore Earth's habits. The behavior we have is the opposite. The line is loyal to the sky. The pulse is loyal to when the line should matter. This does not crown a transmitter with a laurel. It simply keeps pointing the pencil away from the lab and the bus and toward the lane in space where a shard with a pale rim crosses the dark. Numbers once more, compact. Hot-cold Y factors stable to within a few percent. Dummy load runs that flatten everything, including the suspect bin. Local oscillator steps that move the rack's sins while the target stands still. Notch inserts that amputate the feature as a sky tone would suffer. Off-source control fields that show nothing at the cadence, and drift that make the target interesting. Backend diversity that cancels software tricks. Mars logs with no power games at the minute that matters. Clocks that agree. All of this is dull in the best sense. Skeptical escape hatches get their last light. Could an unknown satellite transmit in the protected band with a disciplined tone, hide from catalogs, avoid other bands, and keep time with a schedule that fits better with a moving object halfway to Mars than with any Earth constraint? The protected band is not a force field, but it is a bad neighborhood for people who want to stay anonymous. Could a secret test on the spacecraft tickle a sensor and then vanish while leaving no paperwork? Space agencies are good, not magical. Paperwork exists. Could 2 different labs in 2 countries make the same pipeline mistake in the same week and converge on the same illusion? The cross-checks with old backends and nothing but plain stacking say no. A small scene keep the temperature low. A team eats late noodles in a break room and talks about everything except the thing that fills their minds. Someone mentions a ball game. Another mentions a broken dishwasher. A third scrolls quietly and then puts the phone face down. On that phone is a plot that has become familiar. A thin line drifts with the geometry. A skinny blip sits near a minute on a different world. People with complicated jobs often look like they are doing nothing when they are doing the most. They are waiting to see whether the sky keeps its promises. 2 more hard facts finish the housekeeping. Protected bands reduce accidental contamination to a tiny fraction of the dial. You search there for a reason. And when 3 independent instruments under different roofs produce the same nuisance after you twist every knob that can create a lie, the nuisance begins to qualify as a phenomenon. None of this requires announcements. All of it requires accurate notebooks. Grounded speculation, 1 small step, and stop. The surviving possibilities cluster into 2 families. The first is natural with unusual discipline, a rare maser or plasma process that acts narrower and steadier than the textbooks prefer. The second is engineered thrift, a device that places short, regular energy in the quiet part of the sky and a short, regular disturbance in a plasma on the way. The first family needs a paper that shows the physics without gymnastics. The second needs nothing but patience and more nights where boredom returns at the same time. An open question stays on the table, gentle and firm. If you have tried to remove the lab and the lab refuses to be the culprit, how long do you owe silence before you let the public in on the shape of the question? Professionals answer with protocols and review periods, which protect the work. Outsiders answer with curiosity and taxes, which pay for the work. The next folder in the file is not about clocks or feeds. It is about people who live between those answers and what they do when their patience frays. Before dawn, a thread appears in a corner of the internet where names wear masks. The title is careful, almost bored. The body is shorter than the mood behind it. A handful of dates, a hint about clocks, a pushpin near Mars, and a sentence that reads like someone who has spent months deleting their own adjectives. Replies multiply, then molt into jokes, then return to the one thing that keeps the screen from sleeping. If you line up the minutes, the coincidences stop behaving like coincidences. Picture the poster, not a hero, not a saboteur, just a person whose job has replaced coffee with protocol. They sit at a kitchen table under a single bulb at 2 in the morning because 2 in the morning is when cautious people become honest. Their phone is locked with a strong code. Their laptop has a sticker over the camera. They type slowly. They do not mention employers, instrument names, or coordinates that would burn colleagues who have not signed up for drama. They type like a professional who respects their craft and has run out of patience with a noun. 2 hard facts steady the scene. First, insider posts are usually noise. People remember a few that were true because lies outnumber truths by 100. Second, real leaks do not look like television. They look like small numbers and dull documents and clip phrases that do not give away methods. This thread reads like that. No fireworks, just a clock, a slope, and a reminder that the silence is policy, not physics. The first page narrows to a claim. Late September, a narrowband feature near hydrogen that needs stacking to speak. A housekeeping pulse in a charged particle channel near Mars within the same window after light time is subtracted. The poster writes that teams were told to route questions through a single mailbox and to avoid words that would stick to headlines. They write that the cadence looks like groups rather than a continuous tone. They write that the slope matches what you get when two worlds move, and a quiet transmitter does not bother to compensate. They do not write anything that would let you know which chair they sit in. They have learned that small details are fingerprints. Replies bloom into predictable shapes. Some shout hoax. Some demand proof. A few ask the right questions. Did anyone rotate polarization? Did anyone do an off-source control field at the same elevation? Did anyone nudge the local oscillator and watch the spurs march? The original poster responds with hints that sound like yes, without becoming a confession. Then they stop responding. Vivid image, small and precise, to hold the thread while the room breathes. The post sits on a gray screen. Tiny arrows up, tiny arrows down. A timestamp that reads like a missed train. In the corner of the view, a list of archives that capture everything even when a moderator deletes it. The post is copied, then mirrored, then quoted with errors. The errors become their own chain. Somewhere, a person watches their own words leave home and realizes they cannot bring them back. Numbers for sleep, then we set them aside. The post mentions 2 minutes of useful overlap in some nights after time corrections. It mentions a drift that, when rounded, sits near 1 Hz each minute. It mentions 3 or 4 stacks per hour. It mentions a polarization preference of a few percent. It mentions nothing you could not have guessed if you had followed the right rumors with a notebook. That is the point. The post is not trying to prove. It is trying to keep certain questions from being archived under the word speculation and left there until winter. Skepticism stays at the front of the class. Anonymous threads are where confidence goes to learn humility. People invent maps of treasure because it is easier than digging. People invent conspiracies because reality is slow. Yet style matters. Fakes love theater. Professionals love boredom. The thread prefers rounded numbers to metaphors. It refuses to name heroes and villains. It repeats that the protected hydrogen band is the right place to hide a polite whisper. It notes that conjunction is a curtain the sun provides for free. It reads like someone who has attended too many meetings about managing excitement. 2 more hard facts tie the post to the week in question. A public preprint that had drawn lines between an old signal and a new traveler is quietly withdrawn for revisions during the same 2-day stretch. The thread says the room went still. A set of scheduling calendars across 2 observatories shows late-night blocks with neutral labels at times that follow the same lane in right ascension for about a week. None of that proves intent. All of that looks like people who would prefer that attention mildly evaporate. Grounded speculation, and not one step farther. Why would a professional roll a message into a gutter form instead of whispering to a newspaper? Because newspapers come with names and clocks and employers, and names can be subpoenaed, and clocks can be compared to the time you badge into a room. Also because forms like these reach the exact blend of amateurs and obsessives who will try to rebuild the case with open tools and not stop when a press office says be patient. It is not a noble strategy, it is a practical one. A short exchange inside the thread earns a longer look. Someone asks about Mars Express by name. The poster does not confirm. They only write that an older spacecraft with a long memory felt a tick that did not raise any alarms. They note that flight computers do not lie when nothing is at stake. They add, in a throwaway reply, that a housekeeping channel is not a detection paper. It is a map that tells you where to place your better ears. The reply reads like a person drawing the line between seeing a hint and knowing what the hint means. One more image steadies the tone. In a hallway near a conference room, 2 colleagues stand with paper cups and do not look at each other. One says the word rumor with the same care they would use to mention a medical test. The other says the word clocks. They do not say the word alien. They do not need to. The fear is different. It is the fear of being first with something that will not wear the first sentence you give it. The hallway has seen this before. Most rumors die in daylight. Some do not. Numbers, compact cluster. The thread's claim of 2 minutes of usable overlap is modest. The mention of 3 sites with similar slopes is concrete but non-identifying. The reference to new login tokens that expire many times per day is petty and true to institutional life. The comment about a notch filter that erased the feature for one run reads like someone who has watched a spectrum blink in a way they will remember when they retire. Again, none of this is a verdict. All of it is texture you do not get from people acting out a movie. Skeptical alternatives deserve air. Could the post be a composite hoax taking its cues from public habits and a convenient calendar of conjunction? Yes. Could the post be a reverse leak? The kind where a bored teenager with time zones and a copy of an ephemeris paints the sort of numbers that draw science-shaped minds into puddles. That happens. Could the post be a test balloon from inside a room that wants to know how hard the rumor economy will yank if given a tug? Professionals do not run social experiments during weeks when they need to keep their teams fed and quiet. They pick calmer months. 2 hard facts tie back to the policy we already saw. Embargoes exist for good reasons. Good reasons can still produce bad optics. When people who are not allowed to speak are asked daily whether they have anything to say, some of them will find a way to slide a sentence under the door. Also, the communities that listen at Hydrogen are small enough that a single stubborn rumor with the right shape can keep 4 or 5 observatories awake past midnight for a week without anyone admitting why they all chose the same lane. Grounded speculation, one step more. If a device is speaking in packets rather than tones, a leak does not have to reveal the content of those packets to change the work. It only has to force people to look during a window when a faint cadence can be separated from house noise. If anyone in the room believes the cadence is real, their behavior will change. Calendars will drift. Memos will grow careful. Screenshots will go away. A thread like this is both a symptom and a tool. A gentle, open question rises like a sigh. What is the ethical duty of a person who believes a pattern is real, but knows it does not yet deserve the word discovery? Professionals answer with process. Process protects everyone, including the person who wants to speak. Citizens answer with sunlight. Sunlight protects the idea that we paid for the ears, and we are owed the song. The thread is a compromise. It is also a confession that compromises are ugly. One last scene, soft and short. The thread is archived. Mirrors sprout. A dozen small podcasts mention it, misquote it, and move on to brighter tales. In the rooms where this matters, no one links to it. They do not need to. They know the shape already. They would prefer to earn a sentence they can stand behind in a month. They also know that if the pattern survives, this small, tired post will have its fingerprints at the start of a much taller file. Section ending, a bridge to the next turn. The leak did not add data. It added gravity. Under that pull, old anomalies turn to face the same direction and look less like trivia and more like features of a single design. The next pages lay them out without romance, composition, gas ratios, motive, and path. If the pattern is invention, they will fall apart. If it is real, they will lock together like teeth. A small mineral clue keeps returning. Nickel shows up where iron should walk beside it. The file tries to shrug and move on. The numbers keep tugging its sleeve. Hold an image while the mind settles. Under a quiet hood in a midnight lab, a grain of gray dust sits in a cupped foil boat. A lamp warms the air. A slit admits light, and a spectrograph paints thin emerald and amber threads across a sensor. On one thread, Nickel's lines whisper. Iron's usual companions do not rise above the floor. The printout cools on the bench like a leaf pressed in a book. 2 hard facts steady the table. In our solar system, iron and nickel are close friends. They condense together, alloy together, and travel together in meteorites and planetary cores. Typical chondritic material carries iron and nickel in a ratio that puts iron ahead by an easy order of magnitude, and the metal phase often arrives as iron-nickel alloy that refuses to separate without a furnace. Second, we have learned to see iron and nickel in comets and comet with delicate light. Their atomic lines sit in predictable neighborhoods. When one rises, the other usually follows within reach of the same instrument given patient exposure. Seeing nickel without iron above the same detection limits is unusual enough to demand either new physics in familiar dust or a new story about the dust itself. Cluster the technicals in one breath, then let them rest. The reported nickel feature is modest, a few percent above local continuum after subtraction and smoothing. The line fits within a rounded fraction of an angstrom of the neutral nickel transitions common in low-pressure gas. Integration times are long by design, roughly 30 minutes per stack, folded across nights to deepen signal. Iron lines in the nearest expected set sit below a conservative threshold for the same stacks. Control spectra taken on sunlit dust lanes and on calibration lamps confirm the instrument can see iron at comparable levels when iron is there to be seen. The absence is not a blind spot. It is a choice the sky made. Skepticism has first pick of the tools. Could a lamp or a grating blemish nudge nickel up and iron down? A lamp will confess under calibration, and this lamp did not lie. Could the atmosphere play tricks, raising or sinking one species through telluric absorption? The team corrected against standard stars and watched the telluric bands behave. The nickel feature lived in the same place after correction. Could a software pipeline misplace an iron feature by a bin and wash it out? Two pipelines, one stock, and one written by a person who likes plain code, return the same absence. The iron that ought to ride with nickel refuses to join. A vivid picture clarifies the chemistry. Imagine a skin of material on the surface of a dark shard. Sunlight warms it, photons pluck atoms loose, and the escaping plume paints a faint aura that spectrographs collect like pollen. If the skin is ordinary comet crust, the spectrum should carry a family resemblance to other comets: dust, water fragments, carbon cousins, metals in their usual companionships. If the skin is not ordinary, if it has been processed, plated, melted, or chosen for a property rather than born from one, the family resemblance can break. Nickel loves certain jobs in human workshops. It resists corrosion, accepts plating well, and sits happily in alloys and foams that manage heat. It is not proof. It is a reminder that an unusual nickel profile can belong to machines as easily as to minerals. Two more hard facts keep the floor solid. Space can unbraid friends. Selective sputtering is real. UV photons and ion impacts do not pull all elements equally from a surface. Given the right texture and binding energies, one species can escape more readily. Also, nickel and iron do not always enter the gas phase by the same door. Under cold, slow illumination, a thin, nickel-rich veneer could bleed atoms, while a deeper iron-rich substrate remains quieter. You do not need industry to write this scene. You only need surfaces and light. Numbers for sleep: 1 compact bundle. The conservative iron detection limit in the reported stack sits near a round few parts in 10,000 of the local continuum. The nickel line clears that floor by a few parts in 10,000 and repeats across several nights. The ratio of derived column densities, when pushed through a simple model with rounded cross-sections, tilts toward nickel by several to 1 rather than the opposite. Error bars touch, but they do not embrace. Back-of-envelope mass loss rates, if you force them to speak, hover near grams per second for the metals. Absurdly small compared to volatiles, but stubborn in their consistency. Grounded speculation moves one measured step. If the shard carries layered surfaces where nickel is exposed in patches and iron hides a millimeter below, then a slow rotation under a shallow sun could bleed nickel at a cadence that matches the repeating windows when the radio cadence also prefers to speak. If instead the shard wears nickel on purpose, as part of a radiator, a seal, or an old electrode, then weathering could free nickel in a way that looks intermittent and careful, not the chaotic sprays that natural vents produce when ice veins break and jets wake. Either way, a surface process can write a spectrum that reads like choice. The file checks for natural cousins. Comets have surprised us with metals and gas, including nickel and iron, that appear even far from the sun. Those detections, however, came as a pair. Their ratios puzzled but did not invert companionship. They did not erase iron from a neighborhood where nickel behaves as if it belongs. The shard we are watching writes a different signature. It is not louder, it is tidier in the wrong place. A small scene inside a metal shop on Earth tightens the analogy. A technician anodizes an alloy and then plates a thin nickel layer to make a face that resists a harsh bath. Under a microscope, the nickel coat glints with a faint grain. If you took this piece into vacuum and let photons work it for months, nickel would leave first. Iron would only join when the coat thinned. Space is not a shop, but surfaces do not forget where they came from. Skeptical escape hatches get air. Could the nickel be a stray reflection of a different species misidentified in a crowded patch? Cross-checks against line lists say the fit is honest within rounding. Could interplanetary dust along the line of sight contribute nickel while iron is buried in a different phase? That would smear across fields and nights. The feature follows the shard. Could a coincidence of noise spikes and over-friendly smoothing paint a false line? Reanalysis with coarser smoothing keeps the line. Different treatments of the floor produce the same modest bump when and where the shard is in frame. Another hard fact waits in a different folder. The gas ratios reported for this traveler emphasize carbon dioxide over water by an easy 8:1, rounded. That is not illegal in nature. It is unfriendly to the picture of a classic water-friendly comet. It is friendlier to cold ices that release CO2 while water stays asleep. It is also friendlier to engineered stores that lean on carbon dioxide as a working gas or a coolant because it behaves predictably when warmed. The nickel without iron puzzle does not solve this. It does lean the same way. Numbers again, and enough. If you adopt a simple sunlight sputter model with a grainy nickel coat, the expected nickel atom release can sketch a curve that hums at low power all day and rises when the angle sweetens every few hours, the same way a radio cadence might cluster. If you run an iron template through the same model, the iron curve rises later by a factor that depends on depth and binding, which places it below detection for the same stacks. None of this is a certificate. It is a fit that refuses to embarrass itself. Vivid image, short and clear, to keep the tone. The shard turns like a slow key in a lock. At the rim, a pale green halo tints dust. The spectrum on the screen wears one thin nickel seam, like a thread in a dark cloth. The iron seam that should parallel it is a ghost. The room sits with that absence. It feels less like a mistake and more like a note pinned to the door. Micro layering, tidy and visible. One vivid image you can carry. Two hard facts about iron and nickel's friendship, and about selective sputtering that can separate them. One grounded speculation about layered or plated surfaces that bleed nickel first. One gentle question, the kind that loosens the hand on the pen. If a surface chooses which atoms leave, who chose the surface? We do not crown a verdict here. We set a piece next to pieces that already point in the same direction. Composition that tilts toward choice. Gas that breathes in a ratio that prefers carbon dioxide over water. A radio cadence that behaves like equipment. The next page turns to the breath itself. 8:1 does not sound poetic. It does not have to. It is a rhythm, and rhythms have reasons. Imagine the traveler wrapped in a thin, invisible lung. Sunlight drifts across its face, and the lung answers with a soft exhale that prefers one molecule over another. The plume is not bright. It is tidy, patient, and strangely partial. Two hard facts steady the floor before any speculation tries to decorate it. First, water ice needs a warmer touch to wake. Near 1 astronomical unit, surfaces that climb toward roughly 150 Kelvin begin to let H2O go in earnest. Carbon dioxide is looser. It can leave when surfaces sit near 80 Kelvin, even in places where water would rather nap. Second, many familiar comets are water forward near Earth's distance from the Sun. Carbon dioxide can contribute, sometimes generously, but in classic cases, it does not dominate by much. That is why a reported ratio near 8 parts carbon dioxide to 1 part water keeps pulling the eye. It does not break physics. It leans away from the neighborhood brochure. Cluster the technicals in one breath, then let the air go soft again. Retrievals from spectra and thermal models built for this object keep landing near an 8-to-1 balance between CO2 and H2O release, rounded on purpose. The total mass loss in volatiles is modest for a visitor of this size, tens to hundreds of grams each second rather than fountains. The non-gravitational tug inferred from tracking is small but systematic, on the order of a few millionths of a meter per second squared when averaged across days. The direction of that tug is not random. It tends to align with times when the narrow radio feature comes in tidy clusters. The surface temperature estimates that make the ratio honest prefer a skin that rarely warms above the easy triple digits Kelvin. None of these numbers shouts. Together they hum. Skepticism gets the first swing, as always. Could retrievals be fooled by the fact that we infer water from its fragments and oxygen glow, while carbon dioxide often hides behind proxy bands? That is a known problem, so teams cross-check methods and benchmark against objects we know far too well. The ratio stays high when you swap pipelines. Could a veneer of dust simply be choking water vents, while subsurface carbon dioxide finds cleaner exits? It could, and some comets wear such coats. Still, long coats breed messy, seasonal tantrums and wide plumes. The breath here looks disciplined, closer to a set of valves than a ragged crust. A vivid picture helps the mind hold still. Think of a low-light workshop, the kind clockmakers like. A small wheel clicks forward each minute. Thin tubes carry a coal gas under a faceplate. When a lever rises, a whisper of that gas slips through one port and not the others. Under sunlight, a surface like that could remain too cool to wake water while still coaxing carbon dioxide through narrow throats. If you turn the wheel slowly, the port that opens will do so at a steady cadence. Nothing in that picture needs romance. It needs geometry and thrift. Two more hard facts keep that picture honest. Surface layers can sort gases without anyone designing them. Pores with the right depth and grain can trap frost in a hierarchy of energies. The volatile that binds weakest will escape first when a shallow skin sees dawn. Also, sunlight on a tumbling body does not distribute evenly. A small change in tilt can concentrate heat on repeating patches that breathe when they face the light and fall silent when they roll away. You can get rhythm for free. The question is why the rhythm reads like a metronome instead of weather. Numbers for sleep. 1 compact stack. Water sublimation grows steep above roughly 150 Kelvin. Carbon dioxide responds at roughly half that, which allows activity at distances where water sleeps. The 8-to-1 ratio is rounded from retrievals that swing between 6 and 10 across nights, with error bars that touch but do not erase the imbalance. The inferred outflow speed for CO2 molecules in a weak coma at these temperatures sits near a few hundred meters each second. If you pencil a tiny jet with that speed and a mass flow of only a few grams each second, The recoil it gives the traveler can match the non-gravitational tug we track across a day. If you open that jet for a handful of seconds every few minutes, you spend almost no inventory and still write a detectable signature on both trajectory and spectra. The arithmetic is dull. It is also persuasive. Grounded speculation takes a single step and stops. A device that chose carbon dioxide as a working fluid would not be strange. CO2 is cheap to store in ices and easy to meter through small apertures. It behaves nicely under sunlight and remains available long before water wakes. If the shard carried thermal loops or pressure regulators that vented a little CO2 on a schedule, the plume would look like valves more than geysers, and the mass budget would stay small enough to last for years. The same regular venting would double as a gentle attitude control, pushing just enough to show up in tracking when you stack days and smooth the noise. Nothing in that picture requires signals to strangers. It describes housekeeping that refuses to waste watts. Skepticism stays in the chair. Natural bodies with deep CO2 stores have written surprising ratios before, and some have done so at distances where water is shy. But they usually make a scene at perihelion, when sunlight gets bossy. This traveler thins and thickens with a patience better described as pacing than outbursts. The plume does not fan. It pencils. The cadence in the radio near hydrogen likes the same hours. Weather does not tend to keep time with radios unless both are taking orders from the same wheel. Another angle lives in the physics of temperature and shade. If one facet wears a thin, insulating dust, while another stays bare, the bare facet will overachieve in CO2 release even while nearby water sleeps. If the rotation period places that facet in light for a few minutes each cycle, your plume will switch on and off like a heartbeat. If the plume is narrow and the facet is small, the total mass loss stays tiny, while the dynamical leverage stays useful. That is the recipe for motion without drama. Vivid detail again, different texture. Think of frost trapped in a tight lattice. When the sun touches it, the lattice sighs. 1,000 small pores exhale. If those pores are etched all along one seam, and that seam is aligned with a repeating angle, the exhale becomes a rhythm you can set your watch by. You could build such a seam. You could also inherit it from a violent past that left a ridge or a long crack. Both possibilities survive first contact with the numbers. Hard fact, short and dry. 8-to-1 is a ratio, not a revelation. It does not tell you who built anything. It tells you which ice is working the day shift. It also tells you the energy budget. CO2 wins here because it costs less heat to move. That single fact explains why you can move the traveler slightly without crackling like a summer comet. The tug goes in the ledger column marked steady, not spectacular. Numbers once more, then set the calculator down. If you fold the radio stacks by the period that best fits the CO2 vent window, the signal to noise rises a fraction better than it does under a period that ignores vent timing. The drift of the radio line with time still behaves like geometry, not like a clock that is pretending to compensate. The Mars pulse windows fall near times when the model plume would sweep past the planet's line of sight, once each orbit of the shard around its own axis. Those matches are rough. They are good enough to keep the pens moving. Skeptical escape routes get air. Could instrument biases plus a dusty coma plus seasonal angles conspire to make CO2 look heroic and water look timid? If you stack enough caveats, almost any set of spectra can be bent into almost any pose. That is why teams kick the tires with different reduction codes and why they beg for independent data. The reductions in this file come from more than one pipeline, and they do not hate each other. The water is low. The CO2 is high. The rhythm is consistent within the softness of real observing. Grounded speculation, last step. If the shard is not a factory, it might still be a fossil from one. A skin enriched in nickel and a breath led by carbon dioxide could both be the aftertaste of a surface that was processed a long time ago, then left to sleep until a star woke it a little. In that case, the cadence we see would be the echo of old engineering, carried by a body that forgot its purpose but still follows its habits. If the shard is younger in intent, the same signs look like deliberate thrift. One gentle, open question keeps the room from hardening into slogans. If a traveler chooses to breathe carbon dioxide in neat, repeatable sips while keeping water quiet, is that a survival tactic, a convenience, or language? We do not need to answer tonight. We need to note that the breath, the tug, and the radio hour like to share the same page. Hold one image to bridge forward. A pale rim glows as dust picks up the green, the way sea glass does under a cloudy noon. The plume is a thin stroke, not a brush. A number on a graph tilts by a small, trustworthy angle. The dial near hydrogen grows a shade darker inside its chosen minutes. Nickel shows without iron. CO2 walks ahead of water. The path on the star chart curves as if it knows where it is going. The next folder puts those curves under a lamp and asks whether preference is the right word for a body that seems to choose. The sky keeps receipts in centimeters and seconds. When a traveler slides off its expected curve, the math notices and circles the slip in red. Begin with the picture that lets the mind hold steady. A wall-sized star chart in a quiet room is marked with a thin chalk line that tracks where gravity alone would steer a modest interstellar shard. Beside it, a second line, almost on top of the first, bends by the width of a fingernail across a handspan of space. The difference is not dramatic. It is patient. Over days, the fingernail's width accumulates into a lane change you can neither ignore nor blame on a sneeze. Two hard facts settle the table before stories try to decorate it. First, when we fit a path for a small body, we start with gravity and then add 3 gentle knobs to capture non-gravitational pushes. Astronomers label them with plain letters and simple axes: radial from the sun, along the orbit, and out of the plane. For ordinary comets, those knobs sit near zero and wake briefly near perihelion, when jets of gas throw the nucleus off balance. Second, high-quality astrometry turns those knobs into numbers with small error bars. Post-fit residuals, the tiny differences between where the model says the object should be and where telescopes actually see it, map stubborn habits that physics has to explain. If those residuals herd in one direction for a long run of nights, they are not noise, they are motive. Cluster the technicals in one breath and then let them rest. The residuals for this traveler lean along the track instead of simply away from the sun. The along track term grows during specific windows each night and then relaxes. The out of plane term remains small, which says the pushes respect the orbital sheet more than they try to lift the shard. The radial term is not innocent. It prefers a gentle inward pull during hours when a model plume would exhale. The magnitude of the net acceleration sits in the few millionths of a meter per second squared, rounded to keep the room quiet. The sign and timing of that nudge repeat on a cycle that rhymes with a rotation period inferred from the narrowband radio cadence. None of that is a verdict. All of it is a shape. Skepticism gets first use of the chalk. Solar radiation pressure can mimic tiny engines if the area-to-mass ratio is high and the surface is bright and thin. That trick works best on sheets and foils. Our shard does not act like a foiled kite. Its brightness does not swing like a flake. Its color is dull. Push it with sunlight alone, and you can explain an outward radial term that coasts. You do not get a clocked along track tug that wakes and sleeps on a schedule that likes the same minutes as a carbon dioxide breath and a radio whisper near hydrogen. Another candidate is the Yarkovsky effect, the thermal recoil that rocks give off as they warm and cool. Yarkovsky is a slow sculptor. It favors years, not hours, and it leaves signatures in spin that do not like 1-hour doors. Vivid image, because math becomes kinder when it rides on something seen. Imagine a coin gliding on a smooth tabletop while a fingertip taps its rim, always at the same angle, always for the same short pulse, every few minutes. The coin's path does not turn sharply. It leans more in the direction of the tap and arrives earlier at landmarks than a coin that was never touched. If the taps come at the same point in the coin's rotation, the lean grows in step with that clock. That is what the along track residuals look like after a week, when the fits are honest and the schedules are kind. Two more hard facts stand like bookends. Thrust, even very small thrust, does not have to be continuous to matter. Short impulses delivered on a cadence build a preference that integrates quietly across orbits. Also, if the nozzle is narrow and the working gas is carbon dioxide that flows for only a handful of seconds in each window, the total mass spent can be so small that a dusty coma barely notices while the trajectory does. This is not romance. It is bookkeeping. Numbers for sleep, 1 compact stack. The best fit along track term hovers near a few by 10 to the -6 meters per second squared on nights when the line near hydrogen is strongest in stacks. The radial term is smaller by a simple factor and points sunward when the model's CO2 vent would face slightly backward along the motion. The rotation period that aligns the window centers near around few hours. If you pencil a jet with a mass flow of a few grams each second and an exhaust speed of a few hundred meters per second, opened for about 5 seconds every 5 minutes, the time average push lands where the fits want it. The mass budget for a night's worth of taps stays under a kilogram. The error bars on all of these are healthy. The direction of travel is not. Grounded speculation moves one measured step. If a device aboard the shard is using a metered working fluid to manage either thermal stress or attitude while crossing the inner system, it would ration energy and mass by choosing narrow windows to breathe. The strategy would be to do as little as necessary for as short as necessary in the quiet part of the dial and the quiet part of the coma. The side effect would be a track that arrives early by small amounts on nights when the taps stay on schedule. The sameness of those nights is the tell. Skeptical alternatives get their turn in the light. Could patchy outgassing from natural pockets of CO2 on a spinning rock produce a similar clock if the spin is simple and the pockets are few? Yes, nature is allowed to be tidy, but pockets do not read memos, and their opening and closing usually learn from sunlight that does not keep to 300-second pages. Pockets also do not coordinate with a narrowband feature that waits near hydrogen for the same windows. Could astrometric bias create the impression of a forward tug if one observatory's measurements lean in a way that survives averaging? The bias checks say no. Different sites, different filters, same lean. Another angle rests inside the smallness of the out-of-plane term. Guidance that respects the plane hints at a control aim that values stability over flourish. You get that when the goal is to preserve and encounter geometry, conserve spin health, or protect a delicate structure from thermal whiplash. If drama were the goal, you would see lifts above the plane that are cheap near nodes. We do not see lifts. We see patience. Vivid scene, small and human. A plot on a desk shows a train of dots that should line up with a neat curve if gravity alone were writing. The dots sit a hair ahead of the curve on nights when other files say the radio cadence was easy to fold and the Mars housekeeping ticked. On nights when the cadence is shy and the pulse at Mars stays flat, the dots creep back toward the curve. A pencil taps the desk. Someone says the word preference and writes it in the margin, then crosses it out and writes a long track instead, because a long track will be allowed into the minutes and preference will not. Hard fact, practical and dry. If you can predict not only where a traveler will be, but also when it will arrive a few seconds early on nights when your other instruments like to speak, then you are no longer throwing metaphors at a wall. You are testing a linked system. Predictable early arrivals are a sign of control. They do not reveal who is driving. They do say that something inside the shard respects a clock. Numbers again, rounded on purpose. A day of taps at the cadence sketched above nudges arrival times by a handful of seconds across the arc used for night fits. Stack 3 days, and the early arrival grows to tens of seconds. Translate that into sky, and you move the point by fractions of an arc second, which is large enough for good telescopes to feel when they fold nights and stubborn enough to survive weather. The energy spent is small enough to hide inside the budget implied by the 8-to-1 breath. The line near hydrogen does not need to carry content to keep the clocks aligned. It only needs to be present when the taps occur. Skeptical escape hatches stay open a crack. Could data selection bias creep in if teams throw away nights with messy weather and keep nights that happen to be clean when the cadence liked them? That is why the record includes control fields, and why the fits are run blind with pre-registered windows. Could a subtle clock error between observatories smear the residuals toward an artificial early arrival? 2 independent time standards and barycentric corrections run through different code paths agree within rounding. The early arrivals keep their shape. Grounded speculation, one more measured step. If the shard is not following a destination in our system, it might still be preserving a path for reasons that belong to its own past. A craft that lost companions could continue to fly a schedule, like a pilgrim who keeps a ritual after forgetting the story. The pattern we see would then be inertia of intention, carried by machinery that still works because it was built to work for a long time under a cold sky. A gentle, open question floats at the edge of the chart. When a path behaves as if it has preferences, how do we separate choices made tonight from choices encoded ages ago? The night fits do not answer. They only point. They point toward a profile where tiny, regular taps nudge arrival times on the same evenings that a narrow line steadies near hydrogen and a faint pulse brushes a machine over Mars. The line, the pulse, the taps. 3 quiet habits that like to keep each other company. Hold one image to bridge forward. The shard glides under starlight with a thin halo that glows like sea foam under a street lamp. It does not weave. It leans. On a table, a printout lists brightness in one column and push in another. Albedo, area, mass, and motive line up like gears that either mesh or grind. The next page turns those gears one by one. How shiny is the face? How heavy is the core? What job would require taps this small and this exact? Hold a simple image while the numbers settle. In a dim lab, a black pebble sits under a lamp on a velvet pad. A thin beam sweeps across it, and the pebble answers with almost no shine, a swallow of light rather than a flash. Now imagine that pebble the size of a building, gliding through sunlight, swallowing most of what hits it and letting only a small, steady haze glow at its rim. A few taps of gas nudge it along, not enough to shout, just enough to arrive early by seconds that good clocks can hear. 2 hard facts first. Brightness is not size. What a telescope measures is how much sunlight a body reflects, and that depends on both its area and its albedo, the fraction of light the surface returns. A dark surface can look small even when it is not, and a pale surface can look large when it is only generous with light. Second, non-gravitational accelerations scale with area to mass ratio. Sunlight pushes area, not weight. Tiny light sheets feel it. Dense, compact stones ignore it. When an object shows a small but repeatable along-track nudge, that is hard to blame on sunlight. The arithmetic pushes you toward either subtle thrust or an unusually high area to mass ratio. The photometry here prefers the former. Cluster the technicals in one breath and set them down. Photometric fits across broad filters suggest a low albedo face, something in the single digits %, rounded on purpose. Under that assumption, the absolute magnitude implies a characteristic size in the many tens to few hundred meters, a comfortable, boring range that resists extremes. The light curve amplitude is modest in clean nights, which argues for an elongated but not absurd shape. or for a surface that keeps its reflectivity changes muted as it turns. Thermal estimates, folded with a low albedo, keep the skin cool enough that water happily sleeps, while carbon dioxide handles the chores. The observed non-gravitational term along track sits in the few millionths of a meter per second squared on nights when other signs are loud. That term is too large to be sunlight alone unless the body is a foil. It does not act like a foil. Skepticism gets the first chair. Could a very thin, very broad sheet painted dark mimic the photometry in the push, fooling us into inventing small thrust where none exists? If so, the light curve would breathe like laundry, and the radiation pressure signature would point outward from the sun with a steadiness that ignores clocks. We do not see that steadiness. We see a preference for minutes that keep showing up in the radio cadence and in the CO2 breath. Could a glittering, high albedo face, twisted to look dim fake the low albedo call? High polish leaves specular tantrums, needle flashes that betray themselves as the geometry changes. The nightly stacks are quiet where those tantrums should live. Vivid detail because equipment cannot carry the whole room. Picture two models on a tabletop. One is a matte black brick the size of a loaf of bread, dense enough to feel like a promise when you lift it. The other is a thin, crinkled sheet, same length and width, almost weightless. A desk fan aimed at both does little to the brick and hustles the sheet across the varnish. Our traveler behaves like the brick. When it leans on a schedule. The fan alone cannot explain it. Two more hard facts keep the floor flat. If you adopt the low albedo and the not foil body, the photometry prefers the mass required to keep the area to mass ratio. Ordinary lands where rock, metal, or packed ice would live, not foam. And if you use the measured along track nudge to back out the thrust, a narrow jet that vents only a few grams each second for a few seconds every few minutes is enough. Thrust F equals mass flow times exhaust speed. With a CO2 exhaust speed of a few hundred meters each second, you need only a sliver of mass per tap. The numbers are dull. They also line up. Numbers for sleep, one tidy bundle. Assume an effective radius on the order of 100 meters if the albedo is a few percent. That gives a cross-section of a few by 10,000 square meters. If the bulk density sits near a rounded 1,000 kilograms per cubic meter for a porous body, the mass lands near a few by 10 to the 9th kilograms. Now take the long track acceleration term, a few by 10 to the minus 6 meters per second squared. Multiply by mass for thrust demand, and you get a few thousand newtons averaged across the entire day. That sounds large until you remember it is not continuous. If the system delivers that thrust in short taps of a few seconds every few minutes, the instantaneous thrust is only a few tens of newtons. At a few hundred meters per second exhaust speed, that is a mass flow of tenths of a gram per second during the tap. Total overnight consumption drops under a kilogram. Error bars are healthy. The order of magnitude is honest. Skepticism gets new tools. Could the Yarkovsky effect, thermal recoil from afternoon warmth, paint part of the along track term in hours instead of years if the spin, tilt, and thermal inertia are unusually unlucky? Yarkovsky likes patient seasons. It is unpersuasive at 5-minute pages. Could dusty jets from water hidden under a skin surge and fade in neat slots while staying invisible in all the wrong bands? Water wakes loud. When it claims the stage, it drags dust and draws wings in spectra that we do not have. The talkative gas we do have is carbon dioxide, and it lives exactly where the temperature model says it should. Another angle lives in the way albedo and motive talk to each other. A dark face warms easily where it drinks sunlight and cools quickly in shade. If the surface carries a seam of CO2 plumbed through pores, that seam will answer in repeated minutes as rotation sweeps it through morning. A brighter body might blur those minutes. Dark helps rhythm and thrift live together. The photometry that prefers dark sits nicely beside the timing that prefers clocks. Vivid image, change scale. Far from any planet, the shard rolls at a slow, workmanlike rate, a patient turn every few hours. The rim glows green where dust catches the sun. On its night side, a thin line of frost helps hold heat steady where it matters. Inside, a simple loop of tubing could carry cold. When a valve opens for a breath, a thread of CO2 slips out and pushes. The push is shy and neat, timed by a wheel that is not interested in our attention. If no tubing exists, then a seam of old processed ice does the same job by being where it is and warming when it should. The picture works both ways because physics is generous. Motive hides behind rhythm. Two compact hard facts return to ground the mood. Low albedo increases the size estimate. Larger size at the same brightness raises mass and lowers area to mass ratio, which makes sunlight even less effective as a pusher. That pushes you back to thrust if you want the along track term without a sail. Also, the observed out-of-plane acceleration term is small. If the body were a broad, flimsy sheet with attitude games, small tilts would light up that term. We do not see those tilts. We see a steady respect for the orbital plane, as if someone chose to keep control cheap. Numbers again, then put the pencil down. Take a 5-hour rotation period to match the cadence of radio clusters and vent windows. If each vent delivers a 10 Newton push for 5 seconds every 5 minutes, the duty cycle is roughly 1 in 60. Across an hour, the effective average thrust is 1/6 of a Newton. Across a night, that accumulates into seconds of early arrival on the fit curves. Consistent with the residuals, the CO2 budget for such taps is a few hundred grams total. That sits politely inside the gas ratios we infer without forcing the coma to misbehave. Skeptical escape routes get air. Could the albedo be fooling us because the surface is patchy with bright and dark and we are averaging a lie? Patchwork hides inside the light curve amplitude, and this amplitude is not dramatic. Could a hollow body with strange inertia complicate the way small pushes turn into early arrivals? Hollow does not change along track bookkeeping. It changes how spins wobble. If the wobble were loud, the cadence would smear. It is not smeared. Grounded speculation moves one measured step and stops. If the shard is an artifact, low albedo might be a side effect rather than a design choice. A sun-baked, micrometeoroid sanded shell that has grown dark with age. The same weathering that made it dull could have sealed most pores and left only a few disciplined channels where CO2 still finds short paths to light. If the shard is natural but processed by violence, the same outcome holds. A heat shock can sinter surfaces into dark glass, choke easy vents, and leave one or two tidy throats that write a metronome in gas. One gentle open question asks for patience instead of applause. When a path shows a preference, and the light on the face says dark, and the nudge comes in timed breaths that cost almost nothing. Are we watching a strategy or a scar? If it is strategy, the motive is maintenance. If it is a scar, the motive is inertia that looks wise because nature and engineering sometimes land on the same grammar. Hold one last image as a bridge. The shard, matte as charcoal, carries a pale green aura like a whisper no one is meant to hear. Its path leans by seconds that cooperate with a quiet dial near hydrogen. Mass, reflectivity, and motive have stopped arguing. They sit at the same table. The next page does not weigh the body. It listens to its cadence, not for a greeting, for a structure inside the clusters that might tell us whether we are hearing packets, frames, or empty habit. The difference decides intent. Section ending, soft and open. The brick, not the foil. The dim face that keeps heat close. The tiny taps that choose minutes and refuse drama. If this is housekeeping, it is elegant. If it is design, it is thrifty. Either way, the whisper near hydrogen is not alone anymore. It travels with weight, with shade, and with small choices that add up. We turn the file to decoding next. aware that the quietest signals in the world are often the ones that mean the most. The new section begins in a hush that feels deliberate. What returns at the hydrogen shore is not a lonely tone. It arrives in brief caravans, like small trains that keep the same schedule, each one led by a marker and followed by cargo that never quite repeats yet never forgets itself. Picture the waterfall display again, but closer. The first seconds of each cluster climb a step higher, a little brighter bar that cues the rest. Engineers call such steps preambles because they let a sleepy receiver wake its timing and aim its attention. After the step, the line levels into a nearly flat shelf that quietly carries content while power stays modest. The shelf is not smooth. When you subtract a blurred copy of itself, shallow teeth appear. The teeth are spaced like symbols. You do not need romance to see it. You need patience and a ruler. 2 hard facts take the table before any decoder dreams. First, every receiver lives by synchronization. Without a stable tick, bits blur and patterns turn to rain. A preamble exists to buy that tick. It is a universal trick in radios that need to make sense without wasting watts. Second, narrowband transmitters that drift can still carry symbols if the receiver follows the drift and counts within the moving window. This is why the problem looks solvable even when the line slides about a hertz each minute. You track the slide, then listen inside it. Cluster the technicals in one breath, then let them go quiet. Autocorrelation of the stacked clusters shows a modest bump at lags near a few tenths of a second and a second, rounded on purpose, consistent with a short symbol and a longer framing rhythm. Cross-correlation between nights, after drift removal, hints at a repeating header that fits inside the first seconds of each group. Energy per symbol is low enough that single clusters are stingy, yet folding half a dozen rows deep brings the teeth into view. Polarization splits remain tilted by only a few percent, and the polarity preference stays the same across nights. No strong sidebands betray high-rate modulation. The behavior favors a simple keying scheme on purpose, not a showy alphabet. Skepticism claims the chair, as it should. Could the preamble step be a squint effect from the instrument's gain settling? Settling shows up whenever a spectrometer changes modes, and these stacks do not expose such switches inside a cluster. Could the teeth be an artifact of the folding period itself? Sham folds at periods offset by a few percent flatten the teeth. The real folds bring them back. Could distant terrestrial hardware be painting tidy steps into the protected band? The protected band is quiet by design, and off-target fields refuse to grow the same teeth under the same treatment. A vivid image helps the hands relax. Think of a tide pool at night, while a lighthouse far away turns. The pool is noisy with little ripples, random and soft. Every so often, a faint sweep of light grazes the surface, and the ripples flash in a short line that runs and then fades. If you look once, you chalk it up to luck. If you look for an hour, the sweep becomes the clock the pool is keeping for you. The preamble is the flash. The teeth are the glint on the short waves that rise inside it. 2 more hard facts keep the work honest. In modern radios, simple keying survives best when you cannot afford errors. Amplitude shift keying wastes power and invites scintillation to play tricks. Frequency shift keying and phase shift keying punish noise more gently. A slow phase key can ride a narrowband carrier that drifts if you track the center and let a matched filter do the heavy lifting. Also, many robust systems bury error control close to the metal. Redundancy lives in the sequence rather than in a fancy constellation. If you are trying to talk to a future, you keep the alphabet small. Numbers for sleep, 1 compact stack. The preamble step rises for roughly a second at the start of each group. The likely symbol time lives near a tenth of a second, rounded to keep tempers low. That gives about 10 chances inside a second to lay down a small code. The teeth repeat with a spacing that supports that guess. The group length sits near a handful of seconds. The gap between groups is minutes. The drift rate is near 1 Hz each minute and stays polite across nights. Full depth of 6 to 8 groups improves the correlation peaks by a factor of 2 or 3. Nothing heroic, but enough to move out of noise. No obvious harmonics above a few hertz appear in the residuals after detrending. Grounded speculation moves a single step. A preamble that repeats a simple Barker-like pattern would be enough to lock timing across a drifting carrier without wasting much power, especially if the receiver already knows to expect a group inside a minute window. After that, a low-order phase key could carry a checksum or a tiny block of structured data that expects forward error correction to rescue it when nights are unkind. None of this presumes a conversation partner on Earth. It presumes a device that needs its own housekeeping to survive across years, while friendly ears anywhere can keep time with it. Skepticism asks for more chores. Test the hypothesis that the preamble is fixed by building a matched filter for a short candidate sequence and sliding it across stacks aligned by drift. If the correlation spike appears at the cluster head across nights and disappears on control fields, the case for a real frame marker improves. Try alternative symbol times at round fractions and look for the one that maximizes the neatness of the teeth. If no single symbol time stays best when the geometry changes, the interpretation begins to fray. A small human picture keeps the temperature down. 2 analysts sit in a quiet room with headphones on, not to listen, which would be ridiculous, but to keep the world away while code runs. On one screen, a grid of tiny blue bars sharpens and blurs as parameters change. On the other, a log prints lines that are almost all boredom. Then a single line prints a correlation value that is only modestly larger than its neighbors. No one cheers. One person draws a small star in the margin next to the parameter set that did the least badly. The work is not revelation. The work is chiseling. Hard fact, not glamorous. If the group cadence matches the rotation-derived event windows that move the trajectory early, then the preamble may march in the same calendar pages for reasons that have nothing to do with greetings. A controller that vents at a fixed wheel angle could trigger a status packet at the same angle out of habit. The packet is not a wave to strangers. It is a log entry pushed into space because a cable was cheaper than a sync. The fact that our ears can fold it is an accident of geometry. Accidents are how most of astronomy happens. Numbers again, and enough. Assume a 10-symbol preamble inside 1 second, with a simple binary phase code of +1 and -1. In whitish noise at the observed stack SNR, a matched filter that knows the code can pull a correlation peak a little more than noise would allow. Not much, just enough to point the next hour. If you look for a 30-symbol code, you lose the first seconds to drift and the peak smears. If you try 5, you begin to confuse it with chance. 10 is the kind of tidy round choice humans make. It is also the kind a thrifty system might choose to survive bad weather. Skeptical escape hatches stay open. Could the apparent preamble be nothing more than a bias created by how the instrument records the first seconds of a scan window when the buffer is freshest? That is why you stagger start times within the minute and confirm the step appears wherever you land. Could ground arrays share a firmware quirk that paints the same small step into their stacks? Independent backends that agree make that escape narrow. A vivid image returns to keep the page soft. The traveler turns slowly in a dark lane. For a few seconds, each sweep, something inside it wakes and ticks. The tick pulls a narrow line a shade higher and lays down a string of small decisions in the phase that almost no one will see. Far away, at a red planet, a charged whisper lifts for less than a second in the same hour. On Earth, in a room with windows that never open, a graph grows a small tooth where a matched filter has been told to look. 2 more hard facts bracket the next steps. Decoding comes second. Verification comes first. It is cheaper to convince yourself that a frame marker exists than to extract a payload that may not be meant for you. Also, most systems that must survive long journeys favor checksums that reveal themselves before content, because bad packets should die quickly. If there is a number we can read first, it is the number that says whether reading further makes sense. Grounded speculation, last measured step. If the device is lonely, the packet could contain nothing more than a heartbeat and a rolling count. If the device is in company, the packet could carry a short schedule or a map index that only matters when someone nearby answers. If the device is only the fossil of a system that has lost its partners, the packet continues because stopping was never an option programmed into the wheel. A gentle open question breathes out and leaves the door unlatched. If we are not being addressed, what is the responsible way to listen? Do we keep folding for structure that was never meant to be legible to us? Or do we use the existence of a frame to refine our timing models and let the content pass? The next pages do not strain for payload. They follow the people who are trying to decode in the dark and the reasons those people give for working behind thicker doors than most of us prefer. 3 words circle the room like planets: greeting, warning, map. None of them fits perfectly. Each explains a few seams in the data and leaves the rest hanging like a loose wire. On a whiteboard, someone draws 3 columns. Under greeting, they write patience and thrift. Under warning, they write cadence that escalates. Under map, they write structure without chatter. Then they circle hydrogen and underline drift. The board stays up for a week. 2 hard facts hold the argument to the table. First, the whisper near hydrogen is narrow, structured, and grouped. A short preamble about a second long sits at the head of each cluster. Then a shelf of low power carries shallow teeth that repeat inside that shelf. The carrier drifts by about 1 hertz each minute, steady enough to follow across an hour with a simple tracker. Second, clocks align. After light time corrections, the cluster windows that grow on Earth tend to overlap with brief particle pulses near Mars inside tens of seconds. That marriage is not a verdict, but it refuses to act like a coincidence. Start with greeting, the idea that someone is waving politely from a long way off. The case for it is simple on the surface. The transmission sits near a classic listening harbor, the neutral hydrogen line, where astronomers pay attention and interference avoids them by law. The signal is faint enough to be deniable in single scans, loud enough to reward care. The preamble looks like a gentle knock, the repeated grouping looks like a schedule, and the drift behaves like 2 moving clocks that accept their difference rather than fight it. If a distant builder wanted patient minds to notice without scaring the skittish, this is how you would draw it. Numbers for sleep in 1 compact breath. 10 symbols in a 1-second preamble, group length around 5 seconds, repeat every 5 minutes. Drift near 1 hertz each minute after barycentric correction. Symbol time near 1/10 of a second. Fold half a dozen clusters and weak teeth rise. Duty cycle short, perhaps a few percent. Non-gravitational taps along track on the order of a few millionths of a meter per second squared on nights when clusters are clean. Carbon dioxide outflows at only a few grams each second within short vent windows. CO2 near 8 parts for each part water. The arithmetic is dull. It keeps lining up. Now the problems. Greetings usually spend more power on clarity than this. They do not hide deepened folds that require prior knowledge of cadence. They stamp identity, repeat a prime run, or advertise structure that resists drift and weather. This pattern is modest to a fault. You can call that humility. You can also call it housekeeping, the sort of status tick a device emits for itself while strangers can read it only by accident. Shift to warning, the option that makes the room sit up too straight. A warning would explain the narrow placement, the ritual cadence, and the fact that the preamble is easy to lock once you know where to look. A warning would also usually shape itself to be unmistakable. You do not bury alarms in marginal signal to noise, and then ask a billion-kilometer relay to add a half-second hiccup near Mars at the right minute. Warnings arrive like flares, not like metronomes. There is a middle form of warning that tries to be careful. The cadence could be a hazard bulletin, a keep out lane painted in the thinnest paint that still dries, aimed at partners who already share the key. In that case, the hydrogen placement is not an invitation to us. It is simply a quiet patch that guarantees headroom. The faint pulse near Mars becomes a footprint of some other action that rides the same schedule, not a signal by itself. If you had the code book, the shallow teeth might resolve into a short phrase that changes week by week. Without the book, all we see is the habit. The third column, map, earns its name by refusing to speak in nouns. A map can be encoded as tables and ephemerides rather than words. If the packet buried inside the shelf carries a time tag, a position tag, and an index to a known star list, then anyone within reach who shares the list can know where the device is and where it will be, with no conversation required. The preamble is just the boot code for a small receiver. The narrowband carrier is a thread to follow while you slide your filter. The drift is a feature, not a bug, because it proves the source is not nailed to our tower. A map makes the patient, low-power choices seem rational. You do not spend watts on brightness if your real audience already owns the key. You do not shout when you plan to repeat for months. You keep the alphabet small, embed a checksum close to the metal so bad packets die quickly, and let geometry provide context. If anyone else overhears, they are free to try. The message is not for them. Skepticism keeps the chalk. Could we be forcing categories on a system tick, mistaking log entries for letters? Yes. A controller that vents carbon dioxide for thermal or attitude reasons might trigger a small status burst at the same wheel angle for engineering convenience. The Mars blips would then be footprints of nearby physics that share the same minutes, not replies. You would get packets, not prose. You would get structure, not language. The file reads like that more often than not. A vivid image eases the room back into breath. Imagine two clocks sharing a hallway. One is a tall pendulum in a glass case that keeps time for the building. The other is a small wristwatch that a custodian wears as they make rounds. Once each hour, the custodian passes the case and glances at the pendulum, then writes a mark in a notebook and flips a light off in an empty room. If you are standing in the hall with a very good microphone, you can hear the pen scratch. If you have a camera on the street, you can see the light change in one window. Neither act is for you. Both are readable if you are there at the right minute. Two more hard facts keep the speculation short. The shallow teeth inside the shelf tend to sit in the same places across nights after you remove drift. That smells like a fixed header. The energy per group is low enough that any payload must be tiny and either redundant or compressed ruthlessly. You do not carry poetry on a teaspoon. You carry time, place, and health. Map has one more strength. It plays well with the trajectory taps. If the shard is keeping to a lane by touching a valve every few minutes, it could also be announcing that touch in a short code so that a companion, even a lost one, would know the count. A greeting asks for reply. A warning demands reaction. A map simply lets others predict where you will be without any talk at all. That is thrift and safety in the same envelope. Numbers again, one more bundle for the notebook. If a map-like payload held only a rolling counter, a course time tag, and 3 course coordinates against a simple reference, you could fit it into a few dozen symbols. At 1/10 of a second per symbol, the shelf has room. If you add a small checksum and a code to overcome erasures, the group still fits under 5 seconds. If you space groups by minutes, you buy duty cycle that keeps mass and power low while still giving any partner a steady calendar. The gentle, non-gravitational push that arrives in the same windows would then be a separate system that shares a clock. Grounded speculation takes one careful step. What would a warning look like if it had to be polite? It might modulate content rather than power, encoding an increment when a hazard grows and a decrement when it fades. Over a week, you would see one bit of behavior tilt. If we had that tilt, we could justify the noun. We do not see it. Either the tilt is too soft for the stacks, or the column labeled warning on the board should be erased, and the chalk saved for a calmer day. The people in the room argue in low voices because that is how you argue when you want to keep working together. One says that the ethical duty to share grows if the pattern is a greeting. Another says that duty does not ripen until the structure yields a payload or repeats a train of primes. A third says greeting, warning, and map are all stories for outsiders. For the machine, this is just uptime, micro-layering, visible and simple. One vivid image to carry. A hallway with a pendulum clock, a passing hand, a light that flicks in one window. Two hard facts. Narrowband clusters with a fixed preamble and steady drift. Timing overlaps with Mars pulses inside tens of seconds after light time corrections. One grounded speculation. A tiny map payload that holds time, place, and health. Efficient and legible only to those who already share the key. One gentle open question. If we are not the intended readers, how far should we go to make sense of pages that might be footnotes in a book that is not ours? We leave the board up a little longer. The next pages follow the people who have chosen to stay behind thicker doors, not to hide drama, but to test whether the teeth inside the shelf really bite into any content at all. If they do, even a checksum would be enough to move the conversation from beliefs to proof. If they do not, the packets still serve as clocks. And clocks are enough to keep geometry honest while the sky decides whether it wants to tell us more. The door to the lab has no sign, just a keypad and a camera that pretends to be bored. Inside, people try to read a whisper without teaching the whisper how to lie. At this point, the work stops being romantic and becomes careful. Laptops are air-gapped, phones live in lockers with numbered keys. USB drives wear tamper tape and serial numbers that get read aloud into a recorder before anyone copies a file. A whiteboard lists 3 verbs in block letters: align, fold, test. Under them, a schedule. The cadence is not for meetings. It is for the sky. 2 hard facts stay taped to the wall because they are the guardrails. First, blind analysis is not theater. It is how you protect yourself from wanting something to be true. You pre-register the windows when you expect groups to arrive. You lock the paper, and you do not move the windows after the data shows up. Second, the hydrogen band is intentionally quiet. International allocations keep transmitters out of that neighborhood, so thin lines can live there. If you think you have found structure near that line, the burden is to break it honestly, not to celebrate it. Technically, the room runs a loop that never quite ends. Step 1. Remove drift. A simple tracker follows the narrow line as it slides by about a hertz each minute, laying a straightened copy of the carrier on the table. Step 2. Search for a preamble. They build matched filters for a short family of candidate codes, the kind that robust radios favor because they lock quickly. 10 symbols inside a second is the working guess. They slide each candidate across the first seconds of each group and keep only the ones that raise a small, repeatable peak in stacks from different nights. Step 3. Look for teeth. After subtracting a blurred shelf, shallow combs appear. If the spacing of those combs stays the same after drift removal and does not appear in off-target fields, you allow yourself a pencil mark, not a conclusion. The instruments will not be allowed to invent any of this, so the same code runs on control fields at the same elevations, on data with randomized timestamps, and on data where the tracker is intentionally mistuned by a round percent. Real preambles and real teeth hate the mistune. Artifacts do not care. The file of false positives shrinks. The folder of interesting nights grows fast enough to make the pen taps nervous, but slow enough that no one reaches for champagne. A vivid image steadies the mind. Frosted glass throws soft light on 2 desks. On one screen, the waterfall display looks almost blank until a second overlay draws thin boxes where a preamble should begin. On the other screen, a plot of correlation values rises like a small fence and then flattens. Someone at the desk does not smile. They change one parameter and the fence drops. They change it back and the fence returns. They do not call anyone over. They write down the seed of the random number generator and the exact clock offset they used. Later, a colleague in a different room with a different stack repeats the test and gets the same fence in the same place. Only then do they permit the smallest nod. 2 more hard facts keep the floor level. Error control is usually the next thing you meet after a preamble. Engineers hide checksums close to the metal so bad packets die quickly. Cyclic redundancy checks and short parity blocks are cheap to test when you only have a few dozen candidate symbols. Also, robust systems that expect drift often favor differential schemes so that absolute phase does not matter as much as change. That is why half the code in this lab measures differences between neighbors rather than the neighbors themselves. Numbers for sleep, 1 compact bundle. Symbol time candidates sit around 1/10 of a second. Preamble lengths run from 5 to 15 symbols. Fold depth per night is 6 to 8 clusters, because that is how many the cadence gives you. On a good night, the correlation peak for the best preamble candidate clears its neighbors by a factor of about 2. On a bad night, everything flattens to noise. The false alarm rate under sham fold stays near a few in 100. The room wants a few in 1,000 before anyone will change their tone. Grounded speculation, 1 step and no farther. If a short checksum exists, it might be 8 or 12 or 16 bits long because those are tidy lengths that live in cheap logic. The decoders here try all 3 by sliding a small window over the candidate symbol stream that follows the preamble and asking whether any window produces a distribution of residues that refuses to look random across nights. If one does, that is not content. That is a keyhole. It says a payload exists even if you are not yet invited to read it. Skepticism gets the best chair in the room. Are you inventing frame markers by aligning to noise that you happen to pick because it behaved on Tuesday? That is why the windows are locked before the run. Are you using a folding period that leaks your hopes into the stacks? That is why a different team chooses the period using only geometry and posts it before you start. Are you building your own bias by tuning the tracker to the slope you preferred last week? That is why Mars time lives in the log, not in the rumors. When the housekeeping pulse appears near the same minute after corrections on a night, the filter also perks up. You do not cheer. You write the times down and file them where someone else can rerun the numbers. Another image keeps the blood pressure from climbing. An ethics meeting in a small conference room where water glasses leave rings on the table. No laptops. Printed packets that will be collected at the end. The question on the agenda is boring on purpose. What, if anything, could be released that would be both useful and faithful without priming the world to chase patterns in static? The cautious answer on the first line reads, publish only hashes of the stacks and pre-registered windows so anyone can reproduce the folds. The bolder answer on the last line reads, publish a candidate preamble sequence if 2 independent teams and 1 independent instrument put the spike at the same second for a week. The middle column is blank. 2 more hard facts take the heat out of the debate. The people in these rooms have been burned before by signals that made a beautiful first impression and then forgot to come back. Fast radio bursts taught lessons about repetition and patience. Planet candidates taught lessons about systematics that politely mimicked orbits. When you make a promise in public, you purchase a month of correction if the promise fails. Also, gag orders are rare, but embargoes are not. Coordination offices exist precisely because one team's excitement can erase another team's caution. No one wants that job. Someone has to do it. The room cycles between code and caution. A small group tries template matching at integer fractions of the candidate symbol time to see if any single rate maximizes the neatness of the teeth across nights. Another group pursues content with a leash on. They look for fixed fields that act like time tags or counters that roll. not words that invite headlines. A third group tasks a partner site to run the same code on their raw streams, without sharing parameters, to see whether independent tuning lands in the same alley. When it does, they all become quieter, not louder. Numbers again, then away from the calculator. One preamble candidate, 10 symbols long, raises a repeatable correlation bump near the head of most clusters when the drift tracker is within a few tenths of a hertz each minute of the favored slope. The bump drops if you shift the head by a second. A short candidate checksum of 12 bits produces residue histograms that refuse to be flat when you fold a week, but behave like chance when you fold a night. None of this is a victory. All of it is gravity pulling time toward work. Grounded speculation, one more careful step. If the header carries only a rolling counter and a coarse time tag, then the tooth pattern will stay the same for days and then adjust by a few symbols when geometry changes. That is testable. Schedule the fold so that the expected change falls in the middle of a run, and watch whether the template built from the first half falters in the second. A quiet, human scene pauses the math. A researcher stands at a window and looks at nothing. On the desk behind them is a sticky note with 3 times written in neat pen. The times are when the groups should appear tomorrow if the tracker is honest and Mars clocks agree with Earth. They know that if those times survive a week, they will be asked to argue for secrecy in front of people who prefer sunlight. They also know that secrecy is a poor word for discipline. They bring the blinds down and go back to the code. 2 hard facts finish the turn. If you present a preamble prematurely, 1,000 bright minds will spend their nights mythologizing noise. If you present nothing, someone else will present rumor. The right path is narrow and tedious. Publish pre-registered windows and hashes so the world can test the geometry. Hold the candidate header until independent instruments make it dull. Dull is what survives. A gentle open question remains, not about code but about duty. If the teeth eventually bite and a payload yields 3 numbers that look like time, place, and health, who gets to decide what happens next? The room has answers written in policy binders. The people have quieter answers that involve trust, patience, and the knowledge that once a sentence leaves a mouth, it never comes home again. We step out of the lab into a hallway that smells like dust and air filters. Behind us, code keeps folding. Ahead, another door waits. On the other side of it sit the reasons given for caution that is not silence, for patience that is not delay. They are practical, political, and human. Next, we read what secrecy claims to protect, and whether it earns the right to keep that claim for 1 more week. The door is not locked by fear. It is locked by policy. On a corkboard beside the door, 3 phrases sit on separate cards with thumbtacks that have been pressed down hard. National security, social stability, narrative control. No one likes them. Everyone understands why they exist. Begin with the room where these words grow teeth. A conference table holds glasses of water and printed packets whose corners have been rounded by hands. The agenda is written in a font chosen to calm people who do not calm easily. The first speaker is not a scientist. They talk about obligations to treaties, about frequency allocations, about how a protected band remains protected only if the professionals who use it do not shout every time a thin line twitches. The second speaker is a scientist. They talk about error budgets and pre-registered windows, and how the fastest way to harm a fragile result is to announce it before it has learned to stand. 2 hard facts keep this meeting from dissolving into opinions. First, embargoes are ordinary tools in space science. They are posted, time-bound, and used to coordinate multi-instrument analyses so that caution outruns excitement. Professionals do not love them. They rely on them anyway because instruments disagree in interesting ways, and it takes days to discover why. Second, solar conjunction is real and rude. When a target approaches the sun's glare, ground arrays lose dynamic range, interference rises, and everything that was barely visible yesterday becomes an exercise in humility. Conjunction is a curtain, A smart team uses it to do work that would be battered to death by live commentary. Numbers for sleep, then set the calculator down. A typical embargo window might run 1 to 2 weeks, around a critical observation period. Conjunction near this object buys roughly a month when daylight pushes bowls to the ground. Login tokens now expire every 12 hours. Mirrors that once updated daily are set to lag by 1 day. These are small levers. They add up to time, which is the only currency that matters when signal-to-noise lives near 1. The phrase national security sounds theatrical until you reduce it to simple geometry. If a device in interplanetary space is keeping a schedule precise enough to move a traveler by seconds, then that device is either disciplined by a clock or built to imitate one. Clocks with discipline can be exploited, even if the thing that owns the clock does not care about us. A packet that carries nothing more than time, place, and health can be used to learn not only the device's habits, but also when it is least able to notice a nudge. You do not have to plan a nudge to recognize the duty to keep that possibility from becoming a sport. The phrase social stability is less sharp and more human. Most people do not follow narrowband dynamics. They hear hydrogen and think meaning. If the first public sentence blurs greeting, warning, and map into something that sounds like a story about us, then you get a week of declarations and a month of corrections, and the work that could have cut the error bars by half dies under a noise floor you created yourself. Scientists do not fear being wrong. They fear being rushed into the wrong noun. Narrative control is the most unpopular card on the board. It has earned suspicion by living too close to spin. Yet there's a practical, tired version of it that never makes headlines. If 4 teams are chasing the same faint pattern, and each team uses a different preamble candidate and a different drift tracker, someone has to write the 2 paragraphs that say what is known and what is not in a way that will not embarrass anyone when the third week behaves differently than the first. That is not propaganda. That is stewardship of a small, fragile claim that could become a large, sturdy result if people are not allowed to set it on fire for sport. Vivid image. To keep the heart rate low. Picture a hand resting flat on a paper map while the sun crosses a window. The hand is not trembling. The map is marked with 3 pencil lines that represent the same object under 3 different assumptions about thrust. The lines are close. One arrives early by seconds each night. The person drawing circles around those seconds knows exactly how easy it is to invent a miracle when you owe a press room a sentence. They have chosen to owe the histogram instead. 2 more hard facts hold the wall. The hydrogen band is protected for a reason. It is the quietest harbor we have. Professionals who occupy that harbor have responsibilities to keep it quiet, including to one another. Publishing raw streams from multiple sites without context can invite unintentional contamination when well-meaning people point their own gear at the band and test transmitters they should not be testing. Also, instruments above Mars do not belong to any one team. What looks like an innocent housekeeping tick to a ground group might be part of a scheduled campaign for another science target. Coordination prevents friendly fire between fields that would prefer to remain friends. Skepticism deserves its turn, because secrecy can be a blanket that hides laziness. Could these policies be sheltering a null result that people are not brave enough to say out loud? Yes. Could they be buying time to rearrange language so that a dull truth earns a shine it does not deserve? Also, yes. Could they be warding off embarrassment more than protecting the public? People are people. The antidote to all of these is not haste. The antidote is pre-registered predictions that rise or fall on their own clock. The lab has posted windows. Tomorrow either hits the marks or does not. Grounded speculation takes 1 step. If a short header exists in the clusters, and if it carries nothing more romantic than a rolling count and a course time, there is a way to share without feeding a fire. Publish the locked windows and the correlation improvements when the right code is used, without printing the code. Publish the cross-checks that show off target fields do not perk up under the same treatment. Publish the fact that Mars clocks and Earth clocks prefer the same minute when you subtract light time within tens of seconds. Withhold the candidate header until a second instrument under a second roof produces the same spike at the same second for a week. That plan is not silence, it is a ramp. A small human scene softens the edges. In a hallway outside the meeting, someone leans against a vending machine and stares at a message on a phone that begins with a friend asking for a hint. The person could answer with a hero line and feel like a character in a movie. Instead, they type a sentence about weather and token expirations and tell the friend to read the public scheduler like everyone else. It is not noble. It is discipline learned the hard way. Numbers again, quickly, then back to breath. 2 sites have posted hash logs of their stacks with timestamps that will let anyone verify that drift followers and fold depths were not nudged after the fact. A 3rd site has posted a schedule of planned off-source control runs that bracket the target in elevation each night. A 4th has announced that its Mars partner has agreed to an analysis cadence of every other day during conjunction. These are not headlines. They are stakes in the ground. Another pair of hard facts keeps the case honest. The world has seen instrument ghosts that look like voices. They are fewer in the protected band. They still exist. The world has also seen signals that would not die, that kept their structure through seasons, platforms, and software, until doubt collapsed under the weight of repetition. Those signals did not survive because someone shouted first. They survived because teams that did not like each other still matched each other's numbers. Skeptical escape hatches stay open because they should. If you keep a secret long enough, it becomes its own reason. That is why deadlines matter. The curtain of conjunction is not infinite. When the object returns to easier angles in December, excuses thin. If nothing holds then, nothing held now. If something holds then, the language can sharpen without becoming a sword. One vivid image returns to end the room on a steadier note. A blue-white monitor in an empty control room shows a waterfall so clean it looks like frost. At the top of each cluster, a shade rises for a second, then settles into a shelf that carries faint teeth. Far away, a machine over Mars keeps a diary that does not know it is famous. Between them is a month of light. Inside that month is a place where professionals try to be boring on purpose, because boring is how fragile things survive. Micro-layering, quiet and visible. One vivid image to carry. A hand on a map, 3 pencil lines. The choice to owe the histogram. 2 hard facts. Embargoes are standard and conjunction is a real blindfold that ground arrays cannot remove. 1 grounded speculation. Share the windows and the correlation gains now. Hold the candidate header until 2 independent instruments make it dull. 1 gentle open question. Where's the line between stewardship and paternalism when the clock on the wall belongs to everyone who paid for it? Section ending, open and narrow. The cards on the corkboard will not leave the wall in the next week. They may not deserve to. The curtain is about to fall, and give the quiet its chance to work or to fail. When the sun moves aside, the next section begins with glare and cover, and the simple fact that a month of daylight is the last place to hide in plain sight. What returns after that will either ask for silence to stop or for patience to continue. The sun lifts a bright curtain, and the sky becomes a theater of limits. Signals thin, air shimmers, instruments lose their patience. For a short season, the object and the star share the same frame, and all the easy ways of listening step back, while the difficult ones take a breath and move forward. Picture the ground arrays first, because they're the ones everyone can see. Parabolic bowls tilt toward daylight and meet a wall of soft thunder. Solar radio noise is not a shout, it is a carpet. It raises the floor across the dial and turns thin seams into ghosts. Low angles add heat and refraction, surfaces bloom, side lobes catch glints from hardware that never bothered anyone at night. Schedulers take the hint. The calendars sprout polite phrases that mean closed for weather, even when the weather is the sun. 2 hard facts steady the table. First, near conjunction, the angular separation between target and sun squeezes into single digits of degrees for a while, then creeps into the low teens, which is still unfriendly for thin lines. At separations under about 10 degrees, ground receivers in the hydrogen neighborhood can expect their dynamic range to sag, and interference monitors must work overtime to keep false alarms from multiplying. Second, solar radio flux in active regions happily wanders to levels that turn quiet bands into sand. Even out of flare, the background rises enough to make faint cadence a luxury. This is why conjunction is a curtain, not a crutch. Cluster the technicals in one breath, then let them rest. Arrays switch to maintenance windows, and calibration runs with bright standards that forgive daylight. Some stations try skim scans at dawn and dusk when the sun is low and the target just tolerates an edge shot. Spectrometers narrow their bins and lengthen integration to compensate, which helps a little and hurts a little more. Polarization splits remain useful, but the asymmetry that once felt like a clue now swims in glare. Front ends run colder to keep the floor flat. Back ends change their excision rules to be less aggressive so that the narrow shelf, if it lives, is not cut with the noise. All of this is ordinary. None of it invites heroics. Vivid image, because the mind studies with one. A valley of white bowls sits under a noon sky. Heat shivers the air. Red aircraft lights blur into small coronas. A gull rides a lazy thermal with wings hardly moving. In the control room, a monitor that once showed a neat waterfall now shows snow. A technician sips water and changes the threshold by a round number. The snow does not care. The threshold returns to where it was. 2 more hard facts keep the floor level. Observatories do not simply give up. They pivot. When the sun makes ground deaf, ears in space become the natural option. Instruments that never pretended to be radio telescopes become valuable because they live above the air and keep disciplined time. Mars orbiters carry plasma, dust, and field sensors that write down short pulses whether or not anyone is watching. Solar sentinels at Lagrange points track radio weather in real time. Even when they cannot isolate a narrow line, they can anchor the clocks that decide whether coincidence still deserves that name. Numbers for sleep, 1 compact parcel. For roughly a month, give or take a week, the line of sight stays inside angles that punish ground attempts. The daily windows for marginal geometry hover near dawn and dusk and last a few tens of minutes. Spacecraft recording cadence remains steady, binned in seconds for housekeeping channels, and minutes for higher-level products. Communication passes to Earth preferred times when downlink rates are strong and sun angles are safe, which means delays sneak in. Light time between Earth and Mars sits near 10 minutes, rounded on purpose. All of that adds up to fewer chances and slower loops. Grounded speculation takes a single step. This is the season when quiet tests live best. Not declarations, not contact attempts, but disciplined probes that would be hard to do responsibly during easier nights. A transmitter that respects the protected band might send a polite, narrow query that imitates the object's own cadence by a few percent and waits for a phase tug. A passive listener at Mars might alter a recording mask to widen a channel that usually ignores short pulses. None of this demands a reply. All of it demands a clean notebook. Skepticism sits where it belongs. Conjunction tempts people to see what they already believe. If you think the cadence is real, you will search the snow for teeth and swear you find them. If you think the cadence is housekeeping, you will call every spike a cosmic ray. That is why pre-registered windows matter more now than before. You do not chase patterns during glare. You ask, at 3 times chosen last week, for small confirmations that either survive noon or surrender to it. Hold a second image, different scale. High above the red planet, a quiet machine drifts through a soft shadow. Its instruments tick like a clock that does not care about headlines. For less than a second, one channel rises a notch and drops. No alarms fire. A marker lives in a log that only a few pairs of eyes will read this month. On Earth, a person marks a time with a pencil and checks whether it lands in the window that was posted before the sun grew large. The pencil does not hesitate. A small circle appears. The person says nothing. Two practical facts bend the plot toward space. Space assets do not suffer from noon, but they suffer from priorities. When a Mars orbiter shares a bus with a camera campaign or a relay schedule for rovers, charged particle housekeeping is low on the totem. Coordination is paperwork. Paperwork is finite. Also, solar storms that bother ground ears bother space ears more. A small gust can drape the planet in a veil that turns subtle plasma ticks into noise. This is not drama. This is weather. Numbers again, then away from the calculator. Expect 2 or 3 usable housekeeping passes in a day, hours apart. Expect 1 good skim scan from a ground array when the geometry permits an edge shot in cool air. Expect downlink batches to delay confirmation by hours or days, which means belief should keep wearing a leash. Expect a few false alarms at rates that feel unfair. Expect the correlation curve, if it survives, to slope in the same direction as last week, but more softly. Vivid image, small and stubborn. A blue-white screen in a quiet analysis room shows 3 faint bars like piano keys inside gray. They live where a matched filter says a preamble should be, if drift is tracked within a tight range. The person at the screen toggles a control that nudges the tracker off by a round tenth. The bars fade. They nudge it back. The bars return, not bright, just consistent. Outside, the day is loud. Inside, the room ignores it. Skeptical alternatives get their hour. Could daytime RFI, ugly and wide, accidentally produce small steps at regular gaps when folded by a period you chose from rumor? That is why control fields at similar elevations live on the schedule. Fold those too. If the same steps appear at the same strength, the period is fooling you. Could thermal cycles in equipment mimic cadence when air warms and cools during skims? That is why the test windows include skims in both directions, and why the same code runs on nights from months ago, where nothing interesting should appear. If the same teeth rise there, your filter loves itself. 2 hard facts keep the ethics in frame. The protected band remains protected only if restraint remains real. No one with a license will paint loud queries into hydrogen while the world watches. If anyone tries, they will do it far from curious arrays and at levels so low they barely rank as tests. Also, nothing that happens during glare will be treated as proof. Conjunction produces suggestive hints and pre-registered failures that help tune the next month. The first week of December is where claims go to stand or fall. Numbers for sleep. 1 more cluster. Solar elongation grows by a degree every few days as the geometry relaxes. The schedule notes 3 calendar dates when separation reaches rounded thresholds that ground arrays love, near 10 degrees, then 15, then 20. The team writes those dates on a whiteboard and circles them. The board also lists predicted early arrival seconds for astrometry if the along track taps continue. Those predictions come with fat margins now. The margins will shrink or expand depending on how the glare treated the habits we thought we knew. Grounded speculation, 1 step more. If a partner device exists anywhere near the lane, this is the week they might check synchronization against the shard's quiet tick. That check would not be loud. It would be a short phase nudge that our filters would feel as a tiny change in preamble neatness, not as content. If nothing changes, we learn thrift. If something changes, we learn company. 1 gentle question keeps the temperature human. when the curtain falls and the room must choose which sentence crosses the threshold first. What earns the honor? A claim about a header that 2 instruments can produce on demand. A schedule that predicts early arrivals by seconds with enough accuracy to make grown people wince. A list of Mars ticks that prefer the same minute as the shelves do when light time is subtracted. Or none of these yet, and only the promise to bring numbers that a stranger can verify without borrowing anyone's badge. Hold one last image to carry forward. The sun still blazes, a hard disk that drowns the thin music near hydrogen, but behind it the traveler keeps turning, keeps tipping small breaths into space, keeps whatever clock it has always kept. On Mars, a machine writes the time down carelessly because that is its job. On Earth, a set of posted windows waits like empty chairs. In a few weeks, the chairs will hold either data or nothing. Both outcomes are honest. We walk to the next door in the file. It opens on the quieter games that live inside glare, the experiments you run when no one is looking and you need to know whether the cadence answers in kind. Quiet does not mean idle. It means deliberate. During glare, experiments move indoors. When the big ears squint, the quiet tests slip out of their cases and try to earn their keep. The first test is not a transmission. It is a mirror held up to our own tools. In an empty control room, a technician unrolls a short coax patch and connects a laboratory tone to the receiver's calibration port. The tone is not at hydrogen. It sits off the band where it cannot bother anyone. A tiny, gentle dither rides on the phase, pre-programmed to mimic a 1-second preamble and a shelf of 10 symbols at 1/10 of a second each. The drift injected into the dummy line is a copy of last week's slope, about 1 Hz each minute. The point is not to fool the telescope. It is to see whether the code that claims to find teeth can do so when the teeth are real and the sky is removed. If the matched filters sharpen in the testbed but refuse to behave on control fields in daytime scans, the pipeline earns a small vote of confidence. 2 hard facts keep this honest. Protected bands are protected for a reason. Professional sites do not paint the hydrogen neighborhood with test tones, even politely. All synthetic injections happen inside the instrument chain, behind shields and into cables that never meet the air. Also, every backend worth trusting has a calibration path that lets you add or remove a known pattern without touching the sky. That path is built for measuring gain and phase. During conjunction, it becomes a rehearsal stage for decoders. Numbers for sleep, 1 compact passage. In the dummy chain, the test preamble runs 10 symbols long inside 1 second, just like the working hypothesis. The shelf that follows carries 40 candidate symbols. The drift applied to the carrier sits near 1 Hz each minute, rounded. Full depth matches the cadence we expect in the real stacks, 6 to 8 groups per hour. In this artificial setting, the correlation peaks clear their neighbors by factors of 3 to 5. When the same parameters touch real skims during glare, the peaks shrink to barely over 1. If the tools are sound, that is exactly how it should look. The second test looks outward but stays passive. If the shard truly keeps a clock, then small changes in that clock's phase relative to Earth's benches should show up as tiny shifts in the neatness of the preamble spike, even when the sun is loud. No one asks for content, they ask for a hint of synchronization. So the lab posts 2 pre-registered minute windows, one aligned to last week's best fit cadence, one offset by a deliberate few percent. If the correlation bump prefers the aligned window more often than the offset, when everything else is dreadful, the phase is still there under the carpet. If the offset wins as often as the aligned window, then the preamble may be our invention. A vivid image keeps the mind steady. On a blue-white screen, the waterfall is a blizzard. Over it, translucent rectangles mark the 2 windows like doorways onto an empty street. Most of the time, nothing walks through either door. Sometimes, in the aligned doorway, the faintest shadow crosses and the filter sighs 1 notch higher. No one claps. Someone marks a pencil dot on a paper pinned to a corkboard. A third test belongs to Mars. Ground arrays beg their space partners to widen the binning on a housekeeping channel from 1 second to half a second for a handful of passes. Not forever, just long enough to learn whether the short blips sharpen or vanish when the sampling changes. Spacecraft have rules, and bandwidth is not a toy. But minor changes to a bin width in a low priority channel during a quiet week are the kind of favors teams trade. If the single second ticks split into 2 smaller teeth that still sit in the same minute after light time corrections, you gain confidence that you were not watching a rounding error. If the ticks dissolve, you lower your voice. 2 more hard facts keep the floor level. Housekeeping changes take days, not hours. Requests are weighed against other instruments that share the same bus and the same batteries. Also, solar weather that ruins ground scans can improve or destroy plasma readings unpredictably. A small gust drapes Mars in charged cloth and turns every subtle nudge into panic. Conjunction is a curtain for everyone, just in different ways. Cluster the technicals once more and let them rest. The Mars bin width test asks for halves and quarters of a second under the same range of solar elongations. Light time sits near 10 minutes, rounded, so the overlap windows are posted as broad bars on a shared clock. On Earth, skim scans at dawn and dusk try token folds at the aligned and offset phases. In the dummy chain, the synthetic preamble and shelf run every hour so that the lab does not forget what a healthy correlation looks like. When all 3 lines of work are plotted on the same page, success is not a cheer. It is a gentle refusal to pretend that glare rewrote physics. Grounded speculation takes 1 measured step. If a companion device exists, this is the season when it might test its lock against the shard's cadence with the smallest possible power. That check would not look like a reply. It would look like a fractional improvement in preamble neatness at one phase and a fractional loss at its neighbor, persisting across several days at the same sign. No one builds headlines on that. They build calendars. Skepticism sits in the front row as it should. Conjunction is where biases bloom. If you want the aligned window to win, you will squint until it does. That is why the windows are frozen a day ahead, and why a second team runs the code without seeing which line is which. If you want Mars bin changes to matter, you will draw faces in random sand. That is why the bin test is bracketing days with no expected overlaps at all. If the same little teeth appear in those wrong minutes, your eyes are playing games. One more vivid scene, small and useful. A quiet lab at mid-afternoon, blinds half closed, a cup of tea cooling on a stack of tabs. A plot shows 2 sets of bars, pale on pale. The left set is the aligned window, the right is the offset. They are the same height for most days. On 3 days, the left is a hair taller. On 1 day, both are flat. The person looking at the bars does not write words like signal or proof. They write a small question mark and a date. The date is when separation from the sun will finally reach 15 degrees and the bowls can breathe again. Numbers for sleep, tidy and brief. The aligned window is 5 minutes wide, centered on the predicted group midpoints after drift, because glare forces us to be generous. The offset window sits 5 minutes away. The expected count of usable skims is 2 per day, sometimes 1. The dummy chain correlation peak for the injected preamble sits near a normalized value of 0.3, comfortably above the 0.1 that marks noise. The real skims and glare barely crest Bowman on their better tries. The Mars half-second bin test, if granted, should double the number of bins inside a typical pulse and tell us whether we were averaging a short hill or a single spike. Skeptical escape hatches get their air. Could the preamble preference be an alias of the spectrometer's own cycle against daytime temperature tides? That is why night control scans at the wrong sky coordinates are folded with the same windows. Could the Mars bin changes create artificial structure through firmware quirks? That is why the vendor's lab runs the same change on a bench unit at home and publishes the hash of its raw output. Could the dummy chain cuddle our conclusions until everything looks like success? That is what dummies do. They only prove the code can see what it is told to see. The sky must still be the sky. 2 hard facts steady the ethics. No active queries go in the air near hydrogen from responsible teams. If anything at all is transmitted for a probe, it sits far from protected bands. Low power, short, and aimed nowhere anyone is looking. More a lab exercise than a conversation with a shard. And nothing that happens under glare will be used to crown a claim. At best, the month buys a little discipline, a little practice, and a short list of settings that seem less foolish than the rest. Numbers again, and then a breath. 3 dates are circled on a whiteboard for when solar elongation passes roughly 10, 15, then 20 degrees. 2 nights on either side of each date are devoted to full stacks at the aligned phase, with an extra hour at the offset as a sanity tax. Mars downlink schedules are penciled in gray, with the understanding that weather and priorities will edit them without apology. The dummy chain injections continue at the top of every hour until the board says stop. A grounded speculation. Final step. If the shard listens at all, it listens with indifference. It keeps its clock because clocks are how machines survive long trips, not because strangers ask. The best we can do in this bright season is to make sure our own clocks are not the ones inventing the cadence. If the bars favor alignment by a hair during glare, and the half-second bins resolve hills into hills, then the tools will be ready when the bowls return tonight. A gentle, open question lingers in the doorway. When the easy hearing comes back and the filters sharpen, what will we accept as the first public sentence that is both modest and meaningful? Preamble exists, seen at 2 sites in pre-registered windows for a week. Timing matches, with Mars ticks arriving inside tens of seconds after light time across several days. Early arrivals on the astrometric fits repeat on nights when both of those are true. Or do we wait for content, however tiny? The impatient answer is clear. The responsible answer waits in December. The sun will step aside soon. The bowls will cool. The waterfall will look like frost again instead of steam. All these quiet drills will either pay off in one clean week or be folded into a lesson the field did not ask for and will use anyway. Because this is how work becomes knowledge, when the subject is polite and the world is loud. The sun steps aside. Noise drains from the dial. What was rumor and glare returns to night air, where careful ears and posted windows can finally decide who has been honest. Ground arrays wake like ships leaving harbor. Schedulers peel off the polite maintenance labels and write coordinates again. Dawn skims give way to long, black runs. The hydrogen neighborhood feels quiet in the way empty theaters feel before a performance. All velvet and breath. No coughs. 2 hard facts frame the week. First, solar elongation climbs past 15 degrees, then 20, and dynamic range recovers. Thin lines that drowned in noon come back with their old modesty. Second, the pre-registered windows drawn in glare are still the law. Nobody hunts. Everyone listens where the calendar said to listen, at the minutes written down when it was hardest. A vivid image steadies the mind. In a desert valley, bowls stand with frost on their lips. A red line on a monitor pulses once as a scheduler locks a block. The waterfall plot refreshes and the noise looks like snow again, grains instead of steam. A thin rectangle outlines the first group window. The room is quiet enough to hear the fans. Cluster the technicals in one breath, then rest them. Drift on the carrier returns to its tidy 1 Hz each minute, within rounding. The preamble candidate that behaved in the dummy chain clears a correlation threshold by a factor of 2 on 3 consecutive nights when the tracker holds within a few tenths. Fold depth of 6 to 8 clusters per night raises the shallow teeth into view on 2 sites and teases them on a 3rd. Polarization preference stays at a small, steady tilt, the same sign as before. Off-target control fields taken at matching elevations refuse the treatment and remain plain. Skepticism sits at the front of the room because it earned the chair. Could cooler air and happier receivers be flattering a false positive that barely stood under glare? Maybe. That is why the off-fields run before and after the target with the same windows and the same tracker. If your method loves itself, it will clap for anything. It does not clap tonight. It claps only when the shard passes. Mars keeps its own diary. The half-second bin test finally arrives in a small packet with a terse header. In 3 usable passes, single-second blips from earlier weeks resolve into short hills 2 or 3 bins wide. The times land inside tens of seconds of the predicted windows after light time the way they did before. Solar weather ruins 2 other passes. Nobody complains. People mark what they have and move on. Numbers for sleep. 1 compact bundle. Elongation 15 degrees on Monday, 20 by the weekend. Preamble length near 1 second. 10 symbols long. Symbol time near 1/10 of a second. Group length a few seconds. Gap between groups a few minutes. Drift rate near 1 Hz each minute. Correlation gain for the best preamble template rises from about 0.12 in glare to around 0.22 on the first clean night, then 0.26, then 0.24. Off-fields stay near 0.110. Half-second Mars bins show hills with widths of a second or less on 3 passes that matter. Early arrivals in astrometry return at the level of seconds, on nights when both the shelf and the Mars hills show up. None of this is loud. All of it is obedient. Grounded speculation takes a single step. If the device is running a schedule, it has no reason to change that schedule just because the sun moved. The same wheel angles that open a CO2 valve for 5 seconds every 5 minutes would trigger the same header. The neatness spike in the preamble correlation improves, not because intention grew, but because the weather stopped stepping on the meter. That is thrift, not theater. A short scene in the analysis room shows how belief learns manners. 2 plots share a screen. One is the fence of correlation values for the preamble. The other is a simple arc of early arrival seconds across the night. When the fence climbs, the arc rises. When the fence slumps, the arc relaxes. The person at the screen draws a line through both and refuses to say the word causation. They write the night and the UTC start in the margin instead. 2 more hard facts keep this from becoming a bedtime story. Independent backends still agree. A GPU path, an FPGA path, and an older, simpler spectrometer produce the same uptick when pointed at the same minutes, and produce boredom when pointed away. Also, a second observatory a continent away, working without shared parameters, publishes hashes that verify their stacks were folded on windows posted a week earlier. If the spike were a trick of tuning, the hashes would not care. They do. Numbers again, tidy and brief. 3 nights with preamble correlation over 0.2. 2 with obvious teeth after drift removal and shelf subtraction. 1 with only a hint because Cirrus came and the floor lifted. 3 Mars passes with half-second bins showing hills. 2 passes spoiled by a gust of solar cloth. 4 off-fields per night. All flat. Duty cycle for venting inferred from plume models unchanged within generous error bars. Along track residuals early by a few seconds on the nights when the windows sing. The pencil marks next to those nights look like small, repeated stars. Skeptical escape hatches stay open. Could periodic terrestrial interference at dawn, faint and legal, be slipping through excision and masquerading as a preamble spike at the same minutes for several nights in a row? That is why one observatory ran the windows on an empty patch of sky with the same elevation, the same local time, and the same exorcism rules, then posted the result blind. The spike stayed home. Could Mars housekeeping changes be manufacturing hills by changing firmware? The vendor's bench logs and hashes match the spacecraft format, and the same hills appear in passes that bracket the change. Firmware did not write them. A vivid image keeps the tone low and sharp. The shard turns, pale green at the edge, breathing in sips. A thin, regular tap nudges it along the track so that it arrives early by a heartbeat. The waterfall on Earth grows a little tooth at the head of each group. The diary over Mars lifts for less than a second and then goes back to sleep. None of these acts is theatrical. All of them are consistent. Consistent is what survives December. 2 practical facts pull the thread toward what comes next. Amateurs with disciplined front ends begin to report faint, compatible shapes when they fold on windows the professionals posted. Most of their work is noise. A few plots, clean and neat, look like cousins. That is healthy. It spreads the weight of proof wider than a handful of roofs. Also, a drafting committee begins to sketch 2 paragraphs that say only what the numbers can carry without breaking. Not content, not primes, not a story, just the preamble's behavior, the timing relationship with Mars to within tens of seconds, and the along track lean that returns on schedule. Numbers for sleep, 1 last cluster. If the cadence holds, the winter run offers roughly 30 more nights at useful elongations before geometry drifts again. At 6 to 8 clusters per night, that is a few hundred groups in reach. Fold them and you raise the chance of extracting a small checksum, if any exists. Miss them and you earn a month of explanations. The board in the control room is crowded with rectangles that look like teeth. A gentle open question arrives like a quiet knock when the windows keep their promises and the spike obeys, and the hills over Mars tick inside the same minute after light time. What sentence does the public hear first that is true, modest, and useful? Preamble exists, reproducible across 2 instruments and 2 sites under registered windows for a week. Timing coincidences with Mars housekeeping pulses persist inside tens of seconds across several days after corrections. Along track residuals arrive early by seconds on those same nights. Or do we wait for a checksum? That choice is the hinge between stewardship and theater. Micro-layering, kept in view. 1 vivid image, frost-lit bowls under a black sky. A thin rectangle on a screen. A faint spike that knows when to rise. 2 hard facts. Elongation restores dynamic range. Pre-registered windows still rule the game. 1 grounded speculation. The device did not change. Our weather did. So neatness improved for free. 1 gentle question. What sentence crosses the threshold without teaching the world to hear patterns in snow? The last lines of this night draw a bridge. The easy sky returned, and the numbers behaved the way adults hoped they would. No drama, only obedience. The next page will not pretend the choice ahead is simple. Candor and control will both make their cases, and the shard will keep its clock with or without either one. Our job is to decide whether the quiet we have guarded now buys clarity, or whether it has begun to look like a habit that protects dignity more than truth. The sky has grown quiet enough to hear ourselves think. Numbers behaved. Windows kept promises. What happens next is less a question for spectrometers than for people who sign their names to sentences. Picture a long table under dim lights. 2 drafts lie side by side. One is short, almost modest. It says that a repeatable preamble exists in narrowband clusters near hydrogen, recovered in pre-registered windows across independent instruments and sites for a week. It says that after light time corrections, short particle hills near Mars arrive inside tens of seconds of those windows on several days. It says that nights with the cleanest preamble also show small early arrivals in along track fits. The other draft is longer and braver. It hints at payload, at checksums that might be real, at symbols that may carry more than heartbeat and time. The braver draft promises more than the week can safely carry. The shorter one does not thrill. It would survive December. 2 hard facts stay on the table. First, the hydrogen band is a quiet harbor by law and habit. Responsible teams do not teach the world to hear faces and static there. They publish disciplined tests and pre-registered windows that strangers can fold without borrowing a badge. Second, conjunction's curtain is lifting. Elongation past 20 degrees returns dynamic range to ground arrays. What could be rehearsed only under glare can now be measured without apology. The month ahead is where claims either deepen or dissolve. Cluster the numbers in one breath and let them rest. Preamble length near 1 second, roughly 10 symbols. Likely symbol time around 1/10 of a second. Group length a few seconds. Gaps a few minutes. Drift near 1 Hz each minute after barocentric straightening. Fold depth 6 to 8 clusters per night. Correlation bumps rising from about 0.22 to 0.26 on clean nights. Flat near 0.10 on off fields. Light time Earth-Mars near 10 minutes. Rounded. Half-second bins over Mars resolve single-second blips into 2 or 3 bin hills on 3 passes. Along track nudges of a few micrometers per second squared, with early arrivals of seconds on the same nights. Duty cycle for any venting a few percent, all tidy, none theatrical. A vivid image steadies the choice. In an empty press room, a single sentence glows on a teleprompter. It is plain, almost shy. On another floor, a lab keeps folding the newest stacks. The waterfall looks like frost again. In orbit around a red planet, a machine that never learned the word rumor writes a small number and moves on. Outside, the night is wide and ordinary. The truth is somewhere between those rooms. Grounded speculation takes a single step. If the shard's cadence is a housekeeping clock, December will not ask permission to keep time. The preamble spike will continue to prefer the same windows. The shallow teeth will sit in the same places after drift is removed. And the Mars hills will visit the same minutes when geometry allows. If we have mistaken clever systematics for structure, December will punish vanity. The polite way to learn which path we are on is to publish the ramp, not the banner. Windows, hashes, and plots that strangers can reproduce, with the candidate header withheld until independent instruments make it dull. Skepticism sits in the front row because it has seen this film. Signals with perfect timing have turned out to be firmware quirks that love Tuesdays. Beautiful waterfalls have belonged to faraway equipment that wandered into bands it did not rent. Flames that began as whispers near hydrogen have died when a new backend arrived. The antidote is not silence. It is discipline that survives strangers. 2 more hard facts belong here. Voices that carry beyond one roof are consequences of repetition, not charisma. If a preamble exists, tomorrow's stacks will grow the same spike when folded by strangers on windows posted yesterday. If the spike cannot survive an address change, it was not a preamble. Also, content is expensive. Checksums that refuse to look random across many nights are enough to move the conversation from belief to proof. Until then, time, place, and health are the only honest nouns. A small human picture smooths the edge. A committee drafts 2 paragraphs while a kettle clicks in the corner. No one writes greeting or warning. The nouns on the page are timing and correlation. Someone suggests adding a sentence about nickel and carbon dioxide to remind people that the object's breadth and surface lean in the same direction as the clocks. Someone else erases that sentence. If the preamble does not stand on its own, nothing else matters. Numbers for sleep, 1 more cluster before the pen rests. 30 usable nights before geometry degrades again. At 6 to 8 clusters per night. A few hundred groups. With a symbol time near 1/10 of a second and a 10-symbol header. A short checksum of 12 bits could conceivably be pulled from deep stacks if it exists at all. If it does not, the preamble will still buy better timing, which will shrink error bars on arrival seconds and make small taps harder to ignore. The choice comes down to manners. Candor says to share the ramp now and let the world help push, knowing that noise will rise and patience will be tested. Control says to hold until a checksum is in hand, knowing that leaks will breed stories you did not write. There's a third way that is not really a compromise. Publish the ramp and the windows and the hashes. Do not print the header. Let numbers do what numbers do when they are left in air. One vivid image to keep for the next watch. Frost lip bowls under a quiet sky. A thin rectangle drawn on a screen. A faint spike that knows when to rise. A machine over Mars that blinks for a second and forgets it was ever famous. A shard in the dark that keeps its clock because clocks are how things endure. Two hard facts anchor the feeling. The public paid for the ears. The ears owe the public evidence that can be checked without a passport. The hydrogen harbor remains protected. Professionals owe the harbor restraint. One grounded speculation closes the circle. If there is intent inside the shelf, it is simple and thrifty. Time, place, health. The rest is us. A gentle open question remains, not as a tease, but as a map for sleep. When we speak next, what sentence will be true and kind enough to say aloud without teaching the world to see faces in snow? In late September, a riddle of numbers began to circulate. Slow the breath and widen the frame. The traveler shrinks to a pale seed in a garden too large for names. It turns at a steady pace, the way small things do when no one is watching. Somewhere inside the turning, a habit runs. Once each few minutes, a short breath. Once each few minutes, a quiet tick that keeps time for a machine with other work to do. On another world, a patient instrument lifts for a second and returns to its baseline. On ours, bowls of metal cool under a clean sky and listen. Let the arithmetic soften. Distances round easily. 10 light minutes between worlds. A drift of a hertz each minute. Steady and calm. Windows a few minutes wide. Symbols that last only a fraction of a second and then are gone. All of it modest. All of it repeatable. The universe likes repetition. Hearts, tides, rotations, orbits. Even rumors keep a rhythm when they last longer than a day. Consider the wider comfort. If there is meaning in the shelf, it is not written for us. That may be the kindest possibility. It means we are not under a spotlight. We are at the edge of a workshop, overhearing a clock. Overhearing has its own grace. You can learn without being asked to answer. You can watch without being asked to act. The quiet lets sleep come. Think of the map that patience draws. A winter of nights marked with small rectangles. A handful of minutes predicted each evening. Simple and exact. If the rectangles fill with faint teeth, the story grows on its own. If they stay empty, the story becomes a lesson about how well we can listen and how careful we can be with hope. Both outcomes are generous. Both prefer calm. Let the last images thin to whispers. Green at the edge of a dim shard. Snow on a screen that is almost still. A pencil circling a time on paper. The slow, good weight of a sentence that does not hurry. The clocks will keep their work through the night. If anything needs our attention, it will be there in the morning, patient as the sky.